If you see our agenda, today we are talking about two things. But unfortunately, the person who is supposed to give on experience sharing, he's not really very well, so he's dropped in the last moment. So what we're going to do is that we're going to have only one session today. So, okay, so that's going to be the idea. And before I get into the session, I will introduce myself a little bit later. Let me find out what is kind of a crowd we have. So how many of you use Spark in your everyday kind of companies? Okay, few of you. So how many of you know what is Spark is? Okay, most of you. How many of you done any kind of Hadoop, MapReduce or anything big data? Hive, Big? Okay, most of you have done these things. Okay, how many of you attended any other Spark meetups? Like there is one from IBM, there is one from Sigma. Few of you? Okay, great. So what is the theme of today's meetup is a little bit different. So if you see in our last few meetups, what we used to do is that we used to have this advanced talks where we talk about underneath Spark, and we used to have this beginner talks where we say introduction of different things. Now what happened is that as we observed, lot of other meetups actually doing the same. So if you look at other meetups, they do lot of data frame, lot of SQL, etc. Then we thought, and one more thing is that they also capture the meetups in the videos. So if you see IBM meetup, they are putting out the videos every month they are doing. So what we thought is that we take a little bit different turn altogether and talk about something completely different. Okay, so this meetup and coming meetups will take a little bit different idea than just talking about Spark APIs or runtime, and also talk about why we are doing this, and just to give an idea what we are talking about. So today we are talking about something called distributed systems from scratch, and I say it's a part one. So how many of you here like trilogies? Right, movie trilogies, right? Part one, part two, part three. Right? So some trilogies are created because of market, right? The first part become hit and the second part will come along. And some trilogies are created for because there is no enough time, right? So the thing will go for ever and ever. So that's why we divide it into multiple pieces. So the reason I am saying part one is this idea spans across 10 to 15 hours. Okay, so this is not like one session. So this spans across multiple hours. And I thought no one wants to listen for 15 hours. Right, so I can talk for 15 hours, but I thought no one wants to listen to the thing because I got a feedback recently. So I was doing a training for one of the company, and we give this feedback forms to people saying what you want to see in the future or what you want to see in general. There was one feedback saying we want 10 to 15 minutes videos on YouTube. Right, the reason is that someone figured out no one is going to watch 2 hours, 3 hours. And also I got one of the comment on my blog saying that I don't care about the content, but I really appreciate you talk for 3 hours. So that was our one of the talk on machine learning. So it went around 3.5 hours. And we really not finished everything. Right, so what I thought is that rather than going on this like 3 to 4 hours or going like 6 hours kind of a thing, it's good to divide into multiple pieces. So that's what I started thinking. And also this is the idea of having people attending continuously. So which means this session going to be there, I think 3 to 4 parts over the time. So I'm not going to say it's going to be next meetup itself. So part 2 may come in after 3 meetups also. The reason being is that we want to also talk about other Spark APIs, and we want to also bring some of the other speakers over time. But idea is that this discussion will continuously go to be over multiple meetups rather than we stop here. So that's why I am saying it's a part one. So what we are trying to do is, the theme of the session is, what if we create something from scratch? Right, we learned Spark, we know how the Spark works, we know how to use the Spark in our current work. Now the question is, if we want to do something from scratch, what it takes? Are you able to follow what we are trying to say? Okay, let's move on. So, just to give a brief idea, how many of you seen our videos on YouTube? Okay, most of you. So you know who am I? So my name is Madhukara Phatak. I run a company called Data Mantra, where I consult and train on Hadoop, Spark and other ecosystem projects. And if you want to know more about me, you can go to this website where you can connect on LinkedIn, Twitter, etc. So that's kind of a brief idea. So let us start. Now this is the agenda, let's move on. Now idea was, what it takes to build a distributed processing system like Spark. This was a question I was trying to answer a year back. The question is very simple. If you want to build a distributed processing system from scratch, which looks like a Spark, what it takes? Right? Are you able to follow what I'm trying to say? That's kind of a question we are trying to answer. Now you may be thinking, why? Right? Why you want to do this, right? Already people have fought so much, they've given you MapReduce, they've given you Spark, etc., etc. What exactly you are trying to do? Right, so the idea was, I was going through this Spark history that point of time, and the creator of Spark, the Matthias, what he told is that the initial version of Spark was only 1,600 lines of Scala code. Right, so if you see his very early videos, like 2 or 3 years back, one of the talk he told us that the first version of Spark is only around 1,600 lines of code. Then I thought myself, of course I can go through 1,600 lines of code, or I can come up with those 1,600 lines of code. That's what I thought, right? So I thought if someone can come along and say we can create something which only takes these lines of code, I should be able to do it. So that's how I started. So what happened is that it said first version of Spark had only 1,600 lines of code. Now next question is how good it was. Right? You can say I had only 200 lines of code where only have like 1% of the actual functionality. But when the 1,600 lines of code came, they actually had all the basic pieces of RDD, including distributed system on top of Mesos. So this includes not just your normal APIs, all the RDD APIs, most of the RDD APIs, and it was running on top of a distributed system. Right, that is very powerful, which means you have a very less number of code which can run on a distributed system, and it has all this glory of RDD. Then I thought, that's great. So what I wanted to do was, I wanted to recreate the experience of creating something from scratch, which follows very, very near to how the Spark is done. Are you able to follow? What was the motivation behind it? The motivation behind this was that if the Spark can be created in this 1,600 lines of code, can we recreate the whole experience of exactly starting from scratch and how to build up over a time? Okay? And also what happened is that that point of time I left my job and I wanted to do consulting. And when you start consulting, you don't get any job, right? So that's kind of an idea. So which means you have a lot of time in your hand and no one is really asking what you are doing. So that what I thought, okay, it's okay, even if I take 2-3 months, I'll still be able to do it. And actually it took around 6 months to figure out all the pieces. And then what I did, I took those things and started writing as a blog. So there are a few blogs written over Mesos, Yarn, etc., etc. And when I started to do the meetups, one of the things is, this was the first talk I wanted to give. Now, I was trying to think of this session, and when I was pitching to someone, and someone told me, this looks great, but problem is that most of the people who come to the meetup will ask only one question. The question is, what is Spark? Right? So if I say, I want to build a system like Spark, the obvious question will be, what is Spark? Then I thought, oh, okay, so we should do all the introduction, all the internals of Spark, then we will come to this talk, and it took around 8 months. Right? So it took a long time to get there. So, but we feel now that after going through a lot of these things, people know enough to go this route. So that's kind of a motivation, and that was kind of a problem I was trying to solve. And what I thought is that it's good to have this as a session so people can look at these pieces, and also knowing these pieces also complement your Spark idea. So you may not use this in production, of course, because Spark is there and other pieces are there, but understanding the underneath pieces will really help you to understand a Spark or anything comes after that. Make sense? And also my slides don't have a slide saying that any questions. So if you have any questions, you should ask in between. And another thing is that I normally talk forever and forever. So if you want a break, let me know. Okay? So that's the idea. Let's move on. Now, if you look at distributed system for a very high level, how it looks like today, right? If you look at the distributed system from very high level, how it looks like today. Most of the time, underneath we have a distributed storage, right? You have a HDFS, S3, HBase or whatever it is. You have a distributed storage. On top of that, normally we use this distributed cluster manager. Right, so you have Yarn, Mesos, standalone, etc., etc. Which means underneath we have a storage. On top of that, we have a cluster manager. I'm hoping most of you already know this, right? HDFS and Yarn. Now, on top of this, we have these distributed processing systems, right? Like for example, Spark, MapReduce, whatever, Dremel, Impala, etc., etc., which are built on top of storage and cluster management. And all of your applications, right? Machine learning applications, normal applications, they are called as data applications. So if you look from the very high level, this is what it looks like. Right, so you have a storage, you have a cluster management, you have a processing system, and on top of that, you have the application. Now, when we are saying you want to do something, we are actually talking here. We are not going to recreate all these pieces, we want to use as it is, and we are not going to focus on the applications. So there are going to be dedicated sessions in the meetup talking about experience sharing, where people will be coming along and saying, talking about data application, etc., etc. We are only concentrating on distributed system or processing system. We are not cared about the storage system or the cluster management. Yeah.
So HDFS will also require cluster management, right?
No, so this cluster management is more of a resource management, like a CPU disk. This one is more of a disk and they have their own replication piece. Okay. Right? So this resource management is only for a processing piece, not for the storage piece. All able to follow till here? Okay. Next. Now, what we want to do, and the reason this is possible is, think like if you want to create a web application framework today, right? It is not too much of work. The reason is that there are a lot of standardized framework you can use to create one. So what I'm trying to say, so if you want to create a web application today, right? How many options you have? You have Node.js, you have a J2EE, you have a C# code. There are so many options out there, and if you want to create your own framework, it will not take much time because there are already good libraries out there. Similarly, in the big data, it's becoming like a web framework. Right? So creating a big data processing system is becoming more and more like creating a web framework where you don't have to do everything from the scratch. Why? Because if you want to use a storage, you already have HDFS. Right? You don't have to invent the whole storage system altogether. You can just use the HDFS and it's Apache license and open source. Right? You can directly integrate with it. The second thing is that if you want to do distributed processing, you have Yarn and Mesos, which will take care of all the cluster management, communication, etc., etc. Are you able to follow? Why it is possible today is because of this standardization of frameworks, which means since there are so nice frameworks exist outside, it's very easy to create one rather than doing everything from the scratch. And the way it is working is that if you look at this new generation of systems like Spark, Flink and other people, they're actually leveraging Yarn and HDFS underneath, right? They are not created their own storage or they are not created their own cluster management. What they do, they take these frameworks and they try to implement their processing system. The reason is that it will speed up your whole system, right? How many of you still re-implement HTTP? No one, right? We just take the HTTP and run with it. And thus, what is happening? More and more frameworks get standardized, then what happens? We can build on top of it rather than recreating everything. But it was not true like 7 years back. Let us say, if you are a Hadoop creator, then what you have to do? You have to create everything from the scratch. But today, if you want to create a distributed processing system, there are good frameworks out there which will help you to get to a speed rather than doing everything from the scratch. So that's why I thought it's feasible to do something like that in the very few lines of code rather than trying to say, I will explain you how to implement HDFS, Yarn, etc., etc. So I'm not using that, I'm just leveraging the existing pieces as it is. Now, if you want to build a distributed system, what you do, you start Google searching, right? How people do it, right? If you say, how to create distributed system, that's the query onto Google. Now, what is the conventional wisdom they say, is that read papers. So how many of you tried reading papers? I'm very specific, tried read. How many of you succeeded them? Right, so papers are great, right? They have their own value. But what happens is that if you go and ask anyone, right, so who come from a distributed system, they say, oh, you want to do a distributed system, what you have to do is that there are so set of papers which starts from 1960 to 1990, you have to go through them, and if you understand, then you start implementing it. Right, that's what the conventional wisdom I'm told. And the thing is that you have to understand these protocols, they say, right? You have to understand how this Mesos works, etc., etc. I don't even remember those names. Right? They say not only you have to read the papers, you have to understand these complex protocols. The third thing is that once you get over it, because these papers don't give you code, Now you have to handle the whole complexity of concurrency. Right? What happens if both are trying to get the same data, or what happens if one thing goes down, what happens if one thing is not coming down, all those kind of things you have to understand. And the thing is that they try to tell you that you should do everything from the scratch, right? Read the papers and start implementing. That's very tempting, right? It's very good to do, but I'm not trying to do research. Right? What I'm trying to do is trying to understand what exists out there in a way that I can understand, rather than going through this a pile of papers where you can say exactly what's going on without any one line of code. They give you the equations, etc., nice graphs and those kind of things that nice to look at and read. Maybe after some time you do everything, you read and say, oh, I made a mistake, let me go and fix it. So this is the conventional wisdom. So if you ask anyone to say how to create a distributed system, this is what people say. Now I say I am not against it, but I say there are other ways to do it also. So the other ways to do it is, so this is called as modern wisdom, but it's actually coming from me. Right? So I just put word modern because anything you put with the modern word, it looks good. Right? So that's the idea. So what is the modern wisdom? What I did was very simple. I started to read Spark code. I knew that Spark was created on top of these systems, and I knew that Spark is very good. Why to read the papers? Just start reading the Spark code. What I did was, I took the GitHub and started reading code from 2010. I started to reverse engineer the whole code and started to read it. That's the one thing. The second thing is that I don't want to read the whole protocols because Yarn and Mesos will do all the work. So what I did is that, okay, there is cluster management, they know how to connect, they know how to do heartbeat, everything. I just going to use the Yarn and Mesos because that's what Spark did. Right? Third thing is that I'm not going to care about concurrency because Akka will do it. So how many of you have heard of Akka? Right. So you know Akka is a very good actor-based library which will do the concurrency for me. So what I was trying to do was, I was just going to go through the Spark code and use the existing frameworks to build my own system rather than trying to really reinvent all these pieces. Because what is my wisdom, it says that most of the time, anywhere if you want to create something new today, you are not going to create your own. You are going to leverage this system rather than coming with your own. Okay, so that's what's the idea. So there is no papers in my whole slides because I've never read one. And most of the time I will be talking in terms of code. So I will be showing the code, how exactly things are working, and most of the time the code comes from the Spark itself. Right, so I'm not even saying I have invented these design patterns. They were there, I just took it, I'm making a way of saying I'm explaining to guys. Okay. Now you can say, okay, everything looks fine, but why it is in the Spark meetup? Right? It is not a distributed system meetup, right? It's not even the like a Hadoop meetup. It is a Spark meetup. The reason is that it fits well with our talks. Let me explain you what I mean. So if you look at our talks over a time, if you've seen in YouTube or attended it, we have this kind of multi-layer talks. If you see, if you're talking about application, we had this experience sharing talks, right, where people are coming along from API, JQuery, UI. What they do, they come along and say, this is how we are using. So we already done the application thing. Now we did extensive introduction sessions. Introduction to Spark, Spark Streaming, Spark SQL, data frame, machine learning, etc., etc. Then once we did the introduction, we started doing anatomy sessions, right, where we say, rather than looking at the API, we started talking about this data structure abstraction, like RDD, data frame, etc., etc. Then even last meetup, we talked about Spark on Yarn, where we talked about how the Spark runs on the cluster management. The idea is that we took the top-down approach, which means we started with the application, then we went with the APIs, then once we know the APIs, then we went with the underneath thing, then we went with the cluster management. That was our approach in all the sessions. Right, so next slide. So what we did, we started with the API discussion so that the people know what the APIs are. Then we went with the data structures, then everyone knows the data structure, then we went into runtime, where we talked about the cluster management. Now, top-down approach is great because that helps people to reuse those things in the immediately, right? So if you know the API, you can use it in a place where you are getting paid. But thing is that top-down approach has its own limitations. Because when we are coming from top-down approach, we are kind of saying this is the API and this is how it works. But we never ask why it works like that. right? Because we already knew API, we're just looking at the implementation. Now, what is these talks are actually bottom-up approach, right? So if you go to next slide, so what is the idea of this thing is that what if we go reverse? The idea is that what if I say I only have Mesos and Yarn with me, not the API, not the runtime, not the application, then what happens? Are you able to follow how it is connecting to our earlier talks? The earlier talks was more of a top-down approach where we say we know applications, what to be used, we know the API, then we get into the data structures and the runtime. Now we want to go kind of a reverse, saying that, okay, if I have just Yarn and Mesos, if I given a task of creating something new, what I will be doing. So that's why we thought having these talks will be a good fit for ours compared to whatever we have talked till now. Okay, so what we have thought, let us build the runtime, abstraction and APIs ourselves. So what we have given with the Mesos and Yarn, but we don't have other pieces. We don't have a runtime, we don't have APIs, we don't have those things. So what we want to do is that we want to have our own runtime, abstractions and APIs, and I'm not thinking no one is going to build application on top of it. Right? If someone starts doing application on top of it, I will tell no, don't do it. Right? There is Spark, you should use it. This is only for understanding purpose. This was never meant for creating something for a production, etc., etc. So what we want to do is that whatever we learned in the top-down approach, we want to use all the ideas when we go bottom-up. Okay, so since we already know what is the RDD, we already know how the distribution happens, etc., etc., we will reuse those ideas, but we will go from the bottom-up rather than coming from the top-down, because we already done the top-down, and a lot of other meetups actually doing the top-down, and we think we should do something different. So that's why we thought, let's go bottom-up. Okay. Now, one of the things I have to tell about the design is, it is heavily influenced by the Spark. Because there are many ways to do the same thing, right? If you come into the distributed system, MapReduce does in one way, Spark does in one way, Flink does in one way. So there are many ways to do it, and some parts of time you may say, no, there's a better way to do it. Of course, there is a better way to do it. But the thing is that this design is heavily influenced by the Spark itself. The reason is that this code was written when I was reading the Spark code, and sometimes even I copy-pasted the code, just to make sure that the things are easier, right? So it's heavily influenced by the Spark. The second thing is that a lot of code and design comes from the Spark itself, right? So how they do it, I just kind of think. The third thing is that it did not have any dependency on Spark itself, right? So whatever you're going to talk about or learn about it's a completely new piece of code which I don't have a dependency on Spark. So that was the idea. So we look at the Spark in order to get the motivation and inspiration, but we will not put any dependency, because if we put a dependency, that will defeat our purpose, right? So that's the overall idea. The second thing was, we are only implementing some pieces of the things, right? We are not going to have a session till we have a system which is like Spark. No, that's not the idea. Then it will be goes for like 4 years or 5 years. Right, so the idea is that only implement some of the pieces which are very, very important in the distributed system. So this is not trying to just say implement everything which is there in the Spark. Next one is that when the Spark came along, it only worked on Mesos. So the initial version of the code, what they have is only on Mesos. But the idea was it should work both on Mesos and Yarn. So as we go along, we will see the idea of when we come up with the designs, we make sure that it should also work with Mesos and Yarn. So the initial versions will be on Mesos, but over a time, we'll be also doing it on the Yarn. The reason is that we want it to be on other places. The last piece is that when you talk about Spark, it's a data oriented, right? So you have RDD, you have this input format, etc., etc. My focus is only process oriented, which means I am trying to explore this functional oriented programming piece, not really the data processing piece. Because data processing piece already people know, like how to do input format, how to do distribution, etc., etc. I'm not really concerned about that. What I want to do is that I want to take the RDD and think this is a functional programming. And functional programming on anything. It does not need to be on data. It may be just pure functions without doing anything on the data. So that's kind of focus, because people already understand how the HDFS and MapReduce works. So I'm not recreating the MapReduce piece. I just want to take the abstraction and apply it on top of the Yarn and Mesos. Make sense? Okay. Now, one of the things about what was the state of the Spark in 2010, which will actually help us to understand till where we are going to go. So the Spark at birth is around 2010. They had only 1,600 lines of code. We already talked about it. Now they used only Mesos for cluster management at that point of time. So when the Spark came along, I think most of you know the history of Spark. History of Spark is Spark was created to test the Mesos. Right? So they came up with the Mesos, which is a cluster management system, and they wanted to have a library which can test its capabilities. So what they did is they created Spark, which can actually test that capability. Of course, the irony is that Mesos never took off so much. Spark became big and they became a company, but that was how it's created. So, but what happened is that the initial version of the Spark code only ran on Mesos. At that point there was no yarn, and they didn't even have their own cluster management. So that is one piece. Third thing is that they didn't use Akka back then, because Akka was very immature in 2009 point of time. So they didn't use any Akka. The fourth thing is that they didn't have this idea of DAGs. Right? So we have this multiple stages, etc., etc. At that point of time, those were not there. They were using Scala functions as those abstractions. So there were no DAGs, there were no this multi-stage processing at that point of time. And there were no almost optimizations. So the first version of Spark is more about getting the functionality working rather than the optimization. The reason why I'm telling you all this is our code will be also follow these ideas. Right? So we are not focused on too much on the jar initially. We are focused on Mesos because that was the beginning of Spark. And also we are not really doing much of the optimizations because they came after in the versions. Okay? Okay. Now, the question is how we get there. Right? We know what is the idea. We know what we have to do. It is like, how many of you done project planning? Or most of you are developers here? Okay, few of you. So once you know the problem statement, once you know what are the resources, then you start asking what are my requirements, what I'm trying to do here. And the idea is that we are following the Spark very nearly. Right? So what we did is that we looked at the first version of the Spark, and from there we will see what we need to know in order to do that. Very simple. So in order to do that, we need to know the Mesos. Why? The first version of Spark ran on Mesos, and if you want to create something from scratch, the first thing we want to do is should run on the Mesos. But if you want to do on the Mesos, you should know Mesos first. So how many of you know Mesos here? Okay, few of you. How many of you know yarn? Okay, most of you. Right. So we are not going to start with the yarn for obvious reason, because Spark didn't start with the yarn. So it started with the Mesos. So we want to keep that theme. So we want to learn the Mesos first. The second thing is that once you learn anything, what you do? You do hello world. Right? That's the tradition we don't want to break. So we will do some hello world on top of it. Then we start implementing the things. As of now, this is the idea what I am playing with, and this will go across the multiple talks. So one of the things we will start doing is this functional programming thing that we will try to cover today. But after that, in the next sessions, we want to do these third-party libraries. For example, Spark allows you to add third-party libraries. We want to implement that. For example, support shuffle, right? How to do shuffle. Support aggregations and counters. For example, if you do reduce, that kind of things. You have accumulator, broadcasting, etc., etc. And also have all this running on yarn. So that is kind of a roadmap of our distributed system, right? So this is what we want to do. So how we want to start with? We want to start with the Mesos, where we understand what is the Mesos all about and how we use it, etc., etc. Implement one or two examples just to get a feel of it. Then once we know that, then we start implementing our features. Make sense for all of you? Okay. So what we do is that, let us start with this. Now, what is Mesos? Mesos is an open source cluster manager. Right? So I think everyone understand what is a cluster manager means. What is a cluster manager? Silence. Okay. So what is a cluster manager? You can talk, no issues. You will also come in the video as a voice. Right? Yeah, it does the resource management, the executors, okay? Okay, it does the distribution piece, okay?
If something goes down, it has to take care of fault tolerance.
Okay, it has this fault tolerance using heartbeats, right? It knows which is going down, etc., etc. Okay, so mostly cluster management work is resource management. So what they do, they allocate resources, deallocate resources, and they track the resources, right? And they don't care about the processing piece. Right? They are not about the application layer, they are more of a framework layer where they say, we know how to create a cluster, we know how to manage a cluster, and we know how to allocate or deallocate resources. But after that, it's all up to you to do what to do with those resources. Right, so that was the idea with the Mesos, and the history of Mesos was, in 2009 what happened is if you look at the Hadoop as a framework, the problem with the Hadoop at that point of time was, it can only run MapReduce. Right? It can only run MapReduce on Hadoop in 2009. Now people were happy with MapReduce in first year. They are saying it is great thing ever invented, etc., etc. Everyone started using it, and someone said, wait a second, not everything what I can do can be written in MapReduce. Right? That was the realization after some time that only MapReduce is a problem. So in 2009, what UC Berkeley people were trying to think was, can we come up with a cluster management system where we decouple resource management from the processing piece? Nowadays it's very obvious to us because we have Yarn and other pieces, but back in 2009, 2010, if you are doing Hadoop, you are tied to MapReduce. Right? You can do anything else. So what happened is that the resource management piece, which is called as job tracker and task tracker, it was actually doing both the resource management and processing. Right? If you wanted to do anything else, you cannot use that. For example, Storm came along in 2011, they actually skipped the MapReduce altogether. They implemented their own distributed system. The reason is that they cannot use MapReduce. Right? So the idea in UC Berkeley was, this cannot scale because this is very difficult to implement a new runtime every time. What if we come up with the cluster management piece where any processing engine can run? So that was the idea behind Mesos, and of course Yarn copied a lot of the ideas after that. Right, so Mesos came in 2009. It is built by the same lab which built the Spark also. Right, it comes from the UC Berkeley, and today there is a company behind it called as Mesosphere. Maybe some of you have heard of the company. So this company, it's not the Databricks which support Mesos, there is a separate company for that. And lot of ideas in the Yarn actually inspired by the Mesos. Right, so a lot of things they do same, and there are some differences, but most of the ideas are actually in the Mesos itself. Now one of the things about Mesos is, it is written in C++. Right, in the Hadoop ecosystem or in the big data ecosystem, there are very few systems actually written in non-Java systems. Right, most of the things are written over a JVM, but Mesos is written in C++ for a very specific reason. Because if you want to do a resource management, particularly on a very big cluster, you want to have a control over memory and CPUs. And doing that from a JVM is very, very hard. That's what Yarn people are figuring it now. Right? Doing that from the JVM is very, very hard, but if you implement that in C++ or a native language, you have a complete control over it. Right? So that was the reason why they started it. And another interesting fact is, Mesos come from a university background. They don't care about compatibility, enterprise, etc., etc. Right? What they will say, we are doing a research and we think C++ is the right tool to use. But if you are coming from an enterprise background, everything has to be written in Java. And everything has to be following XML and Java Beans conventions. Right? So that's what people think. That's why the Yarn came from a Hortonworks or Cloudera who come from an enterprise background, and they went with the Java, and Mesos came from a university background. They say, we don't care about those, we just go with the C++. So actually Mesos is implemented in C++, not on Java. But the nice thing is that they give multiple APIs. So we are not going to write C++ code, don't worry. We are going to write mostly the Scala code. The reason is that they support C++, Java and Python and other APIs. So there are multiple APIs for the frameworks. We are using actually the Java API to implement in the Scala. Okay, so the idea of Mesos was, what if we create a cluster manager which only does the resource management rather than trying to do a thing. Now one of the advantages Spark had was, when the Spark was created, there was a cluster manager for them. So what they did, they never cared about the cluster management, they just started with the processing piece. So all the heavy work is done by the Mesos itself. The last one piece I want to concentrate on, how many of you heard Docker? Right, so in Linux system, there is something called C groups and there is something called containers. Actually, containers underneath use the C groups and other technologies in order to do something called resource isolation. So what is the resource isolation idea is, let us say if I have 16 cores on a machine. Now, if you run a process, there is a possibility that it will take over all the 16 cores and other processes will suffer from that. Right? We've seen this, right? You have your Eclipse taking over whole laptop and where you can't even listen to a song. Right? How many of you felt that? I'm taking Eclipse example, but you can take iTunes, whatever the example you like. Right? So we have seen this one process taking over the whole system because there is no fine-grained ways to say what a process should have. Now, what was the idea of Docker or containers altogether was, what if we partition the things in a very small way? The way people used to do was VM. Right? You used to create a VM and so you partition the hardware. The problem is that VM is very heavyweight. In order to create a VM or a boot a VM, it takes a long time. Container is kind of a lightweight version of the same thing. Okay? Now what is the container has to do with the Mesos? The reason is that they use the same idea underneath in order to do the resource allocation. Actually, it is not on the Docker, but underneath they use the C groups and some of the container technologies to do the resource management. The reason is that then they have fine control over your resources. Which means in the Mesos I can say this task only should have one CPU. Then you only get one CPU. Right? You cannot even access other CPUs. But in the yarn, if I say one CPU, there is a possibility that it can go over another CPU also, because in the yarn there is no way to cut off that, as of now. Of course, they are trying to implement that in the new version of the things, but when the Mesos came along, one of the things they wanted to do was that fine-grained resource allocation. Rather than saying, I give you a machine and you do whatever you want. Problem is that we have the machines today which has a very powerful system. I don't want one process taking over it. I want to have multiple processes where there is a fair share across the processes rather than one taking over. So this is kind of a little bit different in Mesos compared to yarn. So Mesos had this very fine-grained information compared to the yarn or even the MapReduce, because MapReduce only had the idea of map and reduce lots. There was nothing else. But yarn is much better than that, but still there are few differences how Mesos works and yarn works. Make sense till here? All are okay? Fine. Now, the question is why we want to use Mesos or any cluster manager, right? What is the reason? The one reason is that they abstract out this managing the resources, because when you are in a distributed system, managing the resources is a big deal. Right? Managing the memory, managing the CPU, making sure that everyone is able to talk to each of them, etc., is a lot of work. And if you use a Mesos, it will abstract out all those things. You don't have to care. It will do a cluster management, etc., etc. So that is kind of a very big reason. The second thing is that will handle the setup and management. Right? If you already have a Mesos cluster set up, for any new framework, you don't have to set up new stuff. You just put a jar and start on it. Right, because if you have to have a cluster for each of the framework, then you cannot maintain those things. Right, that's the problem with the Hadoop ecosystem. Right, if you want to have MapReduce, you have to have a cluster. If you want to have a HBase, you have to have a cluster. If you want to have Impala, you have to have a cluster. How many clusters you will have? Right, managing them becomes more and more difficult. Idea of Mesos is that you don't care about it. You just make the Mesos do all the heavy lifting. You only concentrate on the processing piece. That's the one other thing. Third thing is that having a fault tolerance is very important. Right? In a distributed system, what happens if something goes wrong? If someone has to make sure that they will distribute the task somewhere else, or someone has to make sure that there's information given to the application that something has gone wrong. It's not like blindly you say, we don't know what's going on here. And also, we don't want to have this single point of failures. Right, if you have studied Hadoop 1.0, you know we had this single point of failures. We had this job tracker, which was if job tracker goes down, everything will go down. Right, if name node goes down, everything will go down. So we don't want to have a single point of failure in a distributed system. So what happens is Mesos, actually this is one thing. When the Mesos came along, there was Zookeeper. So what they do, how many of you heard Zookeeper? How many of you know why it is called as Zookeeper? Yeah, so most of the Hadoop ecosystem named after animals. And Zookeeper is the one which kind of make sure that everyone is sane. Right, so that's called as a Zookeeper. But Zookeeper is used for a distributed application kind of maintenance, or more of saying syncing across multiple distributed systems, right? So what they do is that Mesos don't have their own way of doing stuff. If you have a zookeeper, Mesos integrates with you so that you can have multiple masters also. Which means if the one master goes down, you have another master taking over. Which means there are no single point of failures on Mesos because of the integration with the zookeeper. Of course, Yarn integrated with the zookeeper after a long time, but that's kind of an idea. Fourth thing is that it's a very modular and simple API. Now, one of the things about Hadoop versus Spark is how complex is Hadoop. Right? How complex is Hadoop? For example, if you want to do workout in MapReduce, it takes 100 lines of Java code. If you do the same in Spark, it takes like 3 to 4 lines. Actually, that is reflected in Yarn and Mesos also. So we will see some of the example of Mesos today, and when we look at the Yarn, you will understand. If I want to do a hello world in Mesos, it will take 50 lines. If I want to do the same in the Yarn, it takes over 300 to 400 lines. And one of the example, first Yarn came along, they put out an example called distributed shell. How many of you seen that example? Distributed shell on Yarn. It actually goes over 1000 lines. Right? So which means that the idea is that the different kind of background has a different complexity. Mesos come from a background of simplicity, right, where you give very few things to work with. Yarn is saying we will give you everything. Problem is that to make it anything work, it takes us thousands of lines of code. Right, so that's why we are not starting on the Yarn immediately, because the number of code will not fit on any screen. So what I thought was Mesos is much better and much simpler API compared to Yarn. So that's why it do not take much time to port on Mesos, but it takes a long time to port on the Yarn system. Fourth thing is that one nice thing about Mesos is that it supports multiple systems. For example, not only Mesos we are using for our own systems or sessions, a lot of people use Mesos in place of Yarn. The reason is that they have good support for Spark, Hadoop or MPI, etc., etc. So they are built for running multiple different processing systems. Finally, yeah, they give APIs in multiple languages. That's also important, because if you don't want to write Java, if you want to integrate from C++, in Mesos it's straightforward because there's a C++ API. But if you want to do the same on Yarn, it's not straightforward because there's only Java API. So one of the thing about Mesos is they not only have a simple API, they also have nice way of doing from the multiple languages. Okay, so this is the reason why Spark went with the Mesos first, and this is the reason why we starting with the Mesos rather than starting with the Yarn itself. Because most of the time it's a simplicity, and most of the time it's very easy to do compared to what we can do it in the Yarn. Of course, the features are same. You can do whatever you can do in the Mesos also on the Yarn, but it takes a lot of effort. Okay. Now, this is the architecture of the Mesos, and what I'll do is that I will just compare few of the things with the Yarn. So just to get an idea that how it compares, and there are few ideas which are not there here, which is only there in the Yarn. Just to get an idea that everyone understands. So, on the center, there is something called as Mesos master. This one is very similar to your resource manager. Okay, all are able to follow? So we have a master which is similar to that resource manager. Now, on the bottom, we have Mesos slaves, which is similar to your node manager. Okay, so we have a Mesos master, which is called as a resource manager in Yarn, and underneath that, we have multiple slaves, which are called as Mesos slaves, or which are also called as a node manager in the Yarn side. Everyone able to understand? And this is a very typical your master-slave architecture where you have a master and you can have multiple master if you have configured the zookeeper. For simplicity, I have only put the one master, but there is an option to say multiple masters. So only one master will be active and there will be a swap when the one master will go down. Okay? Now, on top of Mesos, whatever the program we write, they are called as frameworks. Okay, so the naming convention is on top of Mesos, whatever the applications we write, they are called as a framework, and the API underneath it is called as a scheduler. Okay, so underneath API is called a scheduler, which is very similar to your application master. Right? On the Yarn, we have this idea of application master, which is actually responsible for doing internal scheduling. So it is called as application master in the Yarn. In Mesos, it's called as a scheduler. Now, the things what they run on top of the slaves are called as executors. Now, if you see, some of the naming convention in the Spark comes from the Mesos itself. Right? In the Spark, we call Spark executors. What is a Spark executor? It is a JVM which is running, which is doing the actual Spark work. What we call these executors or these things in Yarn, we call them as containers. Right, so we call them Yarn containers, but in the Mesos they are called as executors. This is nothing to do with the Spark executor. The naming convention is it is an executor. And if you see in this example, there can be multiple frameworks. So you can have a Hadoop scheduler which runs Hadoop on top of Mesos. You can have a Spark scheduler. Again, this scheduler don't confuse with the actual scheduler. It's just the naming convention. It's a Spark framework. And you can have your own framework which is running on Mesos. And what you do is that in the slaves you have your own executors. You have Hadoop executor, Spark executor, custom executor, etc. etc. Are you able to follow? The idea and architecture is very, very similar to Yarn. Only the naming conventions are a little bit different. So in the Yarn we say resource manager, we call it as a Mesos master here. On the Yarn we call it as a containers, we call it as a executors here. On the Yarn we call them as a application master, we call it as a scheduler in the Mesos. All are able to follow? Yeah.
So what is the major difference between Mesos versus Yarn? Is it just a rewrite of Mesos?
Okay, that's a good question. And I remember there was the same question in Quora, and actually Arun Murthy. How many of you know who's Arun Murthy? He is a creator of one of the creator of the Yarn. He has answered very nicely, but answer do not really say what are the differences. Right? So they say we are doing this, doing this, etc., etc. But idea was Yarn is optimized for Hadoop ecosystem.
Okay.
Compared to Mesos, actually it really shines in the streaming and other applications. So for example, our customers, where are the use cases? A lot of people run Yarn for batch processing or a lot of ETL. A lot of people run Mesos for streaming and interactive querying because Mesos has a much more good support for streaming and other things. Yarn is actually more of a good support for batch. The reason is that they created Yarn to run MapReduce. That's the one, and it comes from different companies. That's only after that, that's the difference. And also they have a very few different things. For example, I will not go to it because we are going to talk about this later. In the Yarn, there is no API for inter-application communication. What I mean by this, for example, let us say you have a MapReduce. Now, once you have a MapReduce, there will be an application master which is running this map and reduce. Now the question is, how to communicate between those? There is no API. They say, you figure it out. Right? So in the Spark, what they use is they use Akka. They use Akka for doing communication. But in the Mesos, there is actually a message passing API. But yesterday I was doing a training and someone told it that is coming in Yarn in 2.7. That message passing API is coming in Yarn. But that was the difference earlier, right? So the Mesos has a little bit different focus compared to Yarn. Yarn was initially really created to run MapReduce in a better way. And after that, they started adding a lot of stuff. But in the Mesos, there are a few things which is very, very tempting for streaming and interactive querying because it was created for Spark kind of an application.
So you said like Spark right now uses the Yarn, right?
Yeah.
But yeah, Spark is more on the you can say stream processing.
Yeah.
So don't you think they should go with the Mesos, as you are saying?
Yeah, okay. So the question is very interesting. Question is, why not Spark says we will just do it on Mesos? Because then they cannot sell. It's like if your software is only on Linux, you are doomed. Because most of the people use Windows and Mac. Similarly, if you already on big data, what is the thing people use? Hadoop. And if you have Hadoop, what do you have? Yeah. So that is kind of a big selling point. The big selling point is that they come to you and say, don't have to create a new cluster. Just put a jar, you start using. But if someone comes and says to you, oh, to use this, you have to create a new cluster altogether, then what you do, you call up your IT guy and say, I need a 40 machine with this cluster. They say no. Right? They don't even want to install anything on the cluster. The nice thing about Spark is that put a jar, everything works. Right? So the Yarn support actually implemented by the Yahoo, not by the Databricks. So Yahoo contributed a big piece of Yarn support. because still, if you see Databricks, they still concentrate on Mesos and standalone. And one of the interesting fact came out recently. How many of you follow Spark Summit? Okay, few of you. What is a Spark Summit is? It's a conference on Spark, runs in US and EU. One of the things what they have did is they did surveys, right? So they went out to people and asked, what kind of cluster management you use? And very surprisingly, a lot of people use standalone, right? Around 60%. Around 30-30 people use Mesos and YAML. Right, so actually if people are doing a lot of Spark, there's a very less usage of YARN happening. But a lot of companies who are already invested in the Hadoop, like Hive, HBase, etc., they are like to run on YARN. So recently I went to one of the company to do the training. There are actually two teams who one use Mesos and one use YARN. The reason is that the one team actually started with the Hadoop, then they came to Spark. So that's why they continue with the YARN. But another team directly started with the Spark. They use Mesos. And what happened is that in the training they asked me, this training is great, but you come back again where you talk about only Mesos, don't talk about YARN. Right? So the reason is that the nice thing about Spark or all these new ecosystem projects are, they support multiple cluster management, which are actually optimized for different things. So if you have different workloads, feel free to use different things rather than have to stick with one of them. So that's kind of a difference or use cases of YARN versus Mesos. YARN versus Mesos, as of now, there may be something coming along in the future, right? So, okay. Now, this one we already talked about. If it goes a little bit slow, yeah. We talked about Mesos master, we talked about Mesos slaves. Inside a framework, there are actually two pieces. One is scheduler and one is executor. What's there a scheduler is, you think like a master. Okay, it's like an application master from where you entry point the application. And what is an executor? Which actually does the heavy lifting of the work, right? There will be multiple executors in the multiple slaves, and there will be only one scheduler which is running in the master. All are able to follow till here? Okay. Let's move on.
Scheduler always runs on master?
Yeah, it always runs on master. So actually there is no concept of, okay. Sorry, so when I mean master is, it's the application master, not a Mesos master. Okay, there is the confusion was because in the YARN, nothing runs on the resource manager. It only runs in, you can have a YARN client or YARN cluster modes, where client means it runs on the machine where you submit it, and cluster means it can run on any container. Very similarly, in Mesos, the scheduler can run on any machine it likes. But it is called as application master, not the Mesos master. Sorry? Okay, so yeah, that's a good thing. So I think in the earlier slide or somewhere I say, next slide, next. Don't go fast. Next, no, let's go here. Yeah, this one. Okay, so okay, I have not specified here. Actually, scheduler is very similar to your Spark driver. So in the Spark driver, actually it's internally implements Mesos scheduler piece. So that's the idea, yeah. Okay. Now, before we start doing any programming on the Mesos, what do we want to do? We want to start the Mesos, and I'm not going to do a setup, because setup, actually there are two ways to do the setup. One means that you can go to Mesosphere and install DEP files, but I come from open source. I like to compile source code. But it takes like 2 hours to compile the C++ code, so I'm not going to run that. So I think I already given in the slides or in the GitHub. If you want to do how to set up a Mesos single node cluster on your machine, just go through that blog, you will get to know what are the things. I have already done on my machine. What we want to do is that we want to start the Mesos and we want to start and look at the API. One of the things about Mesos, again compared to YARN, is it is very simple to start with. There is no XML files to feed up. Just say start, it will give you a master and slave. That's it. Okay, so what we do is that, let us go to a command line. Right? So what we do is that cd, dev, capital D, slash, Mesos, slash, and tap it. Yeah. Build, cd build. So I am using the 0.25 version of the Mesos. Actually, when I started working on this base long back, it was on 0.21, but they have upgraded to 0.25 recently. Now what I want to do is that, let us go back to the slides. I want to start my master. The way you start the master is, you say bin/mesos master.sh, IP, which is the IP I want to start on, and it has this working directory. Working directory is more of like a, which is the temp directory. Now, looks very similar to standalone cluster of Spark? Yes. The reason is that the copy pasted the ideas. Right, so I told you. So the reason is that nice thing about learning this is, it looks familiar to us because who creates different scripts for the different things. So what they have done is that, since we call it as a Mesos master here, I think they call it as a Spark master or something. Right. So what you want to do is that we want to start this. Let us copy paste that line. Enter. No, there you are. Address already in use. Is there something already running? Go to the first space and see. Open that second one. No, not the second application. Yeah. Oh, yeah, it's already in. Stop here. Both of us. Okay. Go to the next. Okay. So I think I was trying out something is in the morning, so it's still running. So what it does is this runs one. If you see CPP, right? It's all runs some C++ code. Now it is the master. Having the just master is not useful. Right, we should have something on the worker also. What we do is that create another tab, and we should give the slave. I think my system will switch off some point of time because it's not connected to charger. Okay, so someone please help me with that. Okay, so what we want to do is that if you go back to the command, the guy who is handling the slides, right? So if you go back to the command, so if you see, on the Mesos master, I have to tell the IP, which IP is the master runs. Now, when you start the slave, you have to tell the IP and the port. This port is very similar to your yarn master port. So, what is the default port in yarn? Okay, so in the cloud arrays are 9026, other places different, 8026 and those kind of stuff. In the Mesos, the default port is 5050. Again, you can change that port. 5050 is a port where the Mesos listens on. So what we are doing, we are telling to the slave that, okay, we want to run a slave where the master is sitting in the 5050. If you see, did we done any configuration? No. The idea is that you pass everything in the command itself and just start using. If you want, you can create a sh.sh files where you give those information, but you don't have to fickle with the XML and those kind of things. Okay, now you say how I know that things are running. Now what is the port we access our yarn UI? 8088. Now one of the nice thing about Mesos is it is the same port for HTTP and your normal communication. There are no two ports for different things. What we can do is that open the browser and go to localhost 5050. Okay, this is the Mesos UI. I'm not sure how many of you seen this because if you have never worked with the Mesos, it looks a little bit different. But this is the UI, and what I wanted to show you is if you go a little bit down, this one. How many slaves? It says activated equal to 1. This is very similar to whatever the yarn says. We have activated, and if you have some slaves which are going down, then it will be there in the deactivated. All able to follow what you have done till now? We talked about our idea, then we now starting the single node cluster for Mesos. Now to do a multi-node cluster is very straightforward. Take another machine, install Mesos and say point to the master. That's it. I think that's what we do it in the standalone cluster also, right? Just put the Spark everywhere and say this is where the master is running, point to it. You don't have to tell anything else. Very similar here, and I have some references in end of the talk where you can say how to do a multi-node cluster. In our example, we are not going to use a multi-node cluster for simplicity, but this is not too different for a single node cluster versus multi-node cluster. Till here, all are able to be with me? Okay, so all are okay till now, or do you want to take a break? Silence. You move on. Okay, so we'll go till 12 and then we'll take a break. Okay, great. Now if you go back to slides, right, so what do you want to do? We have a Mesos, we have understood the idea. Now what we have to do? Let's get to work. Right, let us start doing a hello world example and see what it takes to write a hello world. Next. Yeah. Here. So what we want to do is that when you talk about hello world, the question is what you do about hello world. What you do in hello world. What we did hello world in MapReduce, what was our hello world? The famous word count. But when we come to Yarn, the hello world is not word count. The hello world is something called distributed shell. What is a distributed shell is? It is a kind of application which runs any given shell command on multiple machines. Are you able to follow? The hello world of cluster management is distributed shell. What it does is it runs a given shell command on multiple machines. Okay, because we are not talking about MapReduce or something, we are not going to do a word count, but what we are going to do, we are going to run a shell command across the multiple machines. Here I only have a worker, but this also works for a multiple workers also. Okay, so what we want to do, we want to create our own framework. What it does is very simple. It runs given a shell command on multiple machines. Okay, now if you ask me what is the use case, how many of you use Jeff and Puppet? How many of you heard Jeff and Puppet? Jeff and Puppet. What is a Jeff and Puppet?
Cloud, Amazon Cloud.
Okay, Amazon Cloud. It is your server configuration system. Now what Jeff and Puppet does in a very, very low level is, it runs shell commands on multiple machines. Now I'm not saying that this example will be as good as Jeff and Puppet, but there are use cases where I just want to run a same command across multiple machines most of the time. For example, installations. I want to install Java on 40 machines. What you can do, just take this thing and start running. Sudo apt get install Java, runs on 40 machines, you have Java on top. Right, that's what people do, but this is not for that, this is just for looking at what we can do with this. Right, that's an idea. And in the framework, actually there are three pieces we have to implement. One is called as a client, and one is called as a scheduler, and one is called as an executor. I think we already talked a little bit about scheduler and executor. What is a client? Any idea? It's a program which submits the things. Right? In the Spark, actually driver has both the pieces. It has that main method which actually does the submit, and the scheduler is your context. Right? The context which actually does the work. So it means in the Mesos, the client is the where we actually submit the things, and schedule is the one which actually implements the master, and executor is the one which implements the worker piece. Are you able to follow? So the three different APIs, we have a client API, we have a scheduler API, and we have a executor. Okay, let us start with the client. Now what is the client? Client is a very simple Java code or Scala code which submits the task to the framework. Here what is our tasks? Task is your shell command, some shell command. Now what is the task in Mesos? The word task is used. It is something which takes some resources. Okay, it can be anything. It can be your data processing, it can be your the new generation artificial intelligence. It is something which takes a CPU, RAM or disk. It is something which takes the resources. So tasks do not define exactly what you can do inside, because Mesos is not really interested in the processing piece. It only said task means it has to have some definition of the resources. Okay, now it is very similar to driver program in the Spark. The reason I am taking example of Spark is to compare it. Right? So if you have a driver, then it's very similar to client. And what it does is, from the client, how we create a context? We create a context in the driver. Everyone agrees? Similarly, we create an instance of a scheduler in the client itself. So what do we do? We have a scheduler, we create an instance of the scheduler, and we use Mesos driver to run it. So in Spark, what we do, we use a Spark submit, right? So what it does, it takes your driver and runs on the Yarn application master. In the Mesos, that application master API is called as Mesos driver. What client does is, it does the creation of instances of your scheduler and says, take the Mesos driver, you start this anywhere you want, right? Whatever the application master kind of thing you want to run. Now, one of the things about Mesos is, whenever we work with the Mesos APIs, let us say I want to say a task, I want to say a client, it internally uses protocol buffers for serialization. So how many of you heard protocol buffers? Okay, how many of you heard Avro? How many of you heard writables? Right. So what is the Avro protocol buffers are? They are serialization framework from different companies. For example, you may have heard about Thrift server. In the Hive, you may have heard of Thrift server, right? Thrift is another library from Facebook. Avro came from the Hadoop itself. Then protocol buffer comes from the Google. So internally, Mesos uses protocol buffer for serialization. Okay, now you say, why I care about it? The reason is that the API looks a little bit different than any other API. How many of you learned design patterns some point of time? Okay, how many of you use design patterns? Oh, a lot of you. Okay. In the design pattern, how many of you remember there is a factory and builder design patterns? Right? So in the Mesos, lot of places we follow builder design pattern. So what you do is that whatever the request you want to create, you create using a builder pattern over a time. Okay? So idea is that underneath it uses the protocol buffers and the API uses the builder API. So though we write in the Scala, since we are using a Java API, it looks a little bit different, out of place in Scala. There is one API created by Twitter, which is for Mesos on Scala. But I'm not using it because I just want to use the native API given by the Mesos. But if you want to do Scala on top of Mesos, there is other option of using a wrapper around this Java API created by Twitter. But I'm just using the Java API just to be near to the as much as possible to the thing. So what Mesos uses? Mesos uses the protocol buffer. I think we have talked for a long. It is time to look at the code. Right? In the reality, how it look like. Okay. Let us go to the IntelliJ. It is the same drill. I think we have shared all the code on the GitHub. Feel free to take a look at it when you go home and those kind of stuff. Now, if you come down a little bit, I'm hoping you are able to see the code. Right. So, our main method is called as a distributed shell. The reason is that our application, I want to call it as a distributed shell. And if you see, we have a main method. All are able to follow till here. So what we have, it's an entry point. That's what it's called as a client. Now inside that, I told you it uses the builder design pattern. If you see, the first thing what I want to do is I want to create a new framework. Why? I told you whatever runs on top of Mesos is called as framework, and first thing I have to do is create an instance of a framework. How I do it? I say framework info new builder. Actually, this framework info is one of the model class. That we have this different model class in top of Mesos. What we have is framework info new builder. Then what are the things we are giving? What is this set name? This is similar to whatever the name you give it in the Spark, right? In the context we say what is our master, then there is a name to the application, or in the MapReduce also we give a name in the job API. So it is a name of the application. We say our application name is distributed shell. And actually it has the option of this user and role. What may be this one? This is your authentication and authorization. So Mesos actually supports authentication and authorization, which is very similar to your MapReduce applications. In the MapReduce application, I can tell which user is running this so that you have some permissions underneath storage and etc. etc. Here what I am saying is that my user is no one and I am the admin, star. I don't care about the roles, but when you are building a real application, you may send some of the information. And another thing the Mesos has called as checkpointing. So what is checkpointing? How many of you know, in the yarn, if the application master goes down, there is a checkpointing mechanism. Why? Because when it comes back, it can actually start from the earlier state compared to starting from the zero. And again, these ideas are actually there in the Mesos also. And what I'm trying to say is that I don't care about those things as of now. Just say false. And any idea what are these things? What is timeout? Timeout is that how much time I have to wait before I tell this is not working anymore. For example, you have a client, application, etc., etc. They are communicating through each other and Mesos is tracking it. Now, if you send a heartbeat And after how much time, if you don't get any reply, you have to say it is failed now. I have to restart. The meaning of 0 is infinite time. Okay, I don't care about the timeouts. As of now, I just want to do a hello world. It's an infinite time. I'm never going to be killed. I'm always going to be up there. But normally what we do is that in the Hadoop, we have this 600 millisecond timeouts. Right? If your mapper or reducer is not coming out in the 600 milliseconds, then you start seeing this error saying that the mapper or reducer is killed. The reason is that there has to be a heartbeat going on in the distributed system. If something is lagging, it's good to kill it rather than waiting forever to come back. Okay, so finally we say build. So this is very similar to builder factory. What we do, we create an instance and we keep on setting these different values, and once everything is built, what we do, we say build, and what we get back? We get back a framework object. And what is this framework object? This is kind of a configuration, right? What is the name? What kind of a timeout you want? Do you want a checkpoint or not? And I have only covered few of the things. Actually, there are some more APIs which you can use for different scenarios. Okay, let us come down a little bit. The second thing what I am going to do is, I am going to create an instance of my scheduler. Okay, this is very similar to creating a Spark context. Right, so what I am doing is that I am creating an instance of my scheduler which is called as Scala scheduler. I am not going to explain what is that, we will look into that next, but the idea is that I have created an instance of my scheduler. Then actually what I am doing is that I am submitting the task. So here what I am doing is that even before running it, I just tell when you run this. So this is not dynamic submission as of now. To simplify, what I have done is that I created an instance of scheduler and just submitted all the tasks which it has to run when it comes up. But normally we don't do that. What we do is that we run everything and say keep on dynamically submitting it just to make sure that the things are simple. What I have done, I just told that create a scheduler and submit a task. Now where the tasks are come from? From the command line. So this args underscore star. Again, if it comes from Scala, you know we love underscores. Okay, what I mean here is that arguments is your array, whatever the array, take all the things what are there the arguments. So this is capable of running multiple things also. You can send multiple commands from the command line. You can run multiple at a time rather than have to do one by one. So what I did, take whatever the arguments from the command line, just execute them. They become a task. We'll see what are the tasks, etc. in the next slide, but this is the idea. You created a scheduler, then you say submit task. But this is not enough because there has to be somewhere we have to say where is the Mesos setting and who's the driver. So that's where we are doing this one. In this example, we have hard coded it. We are saying which is my Mesos URL, which is very similar to your master in Spark. Right? We say yarn master, yarn client, Mesos, Spark, etc. etc. So what I'm saying is my Mesos URL is 5050. I think everyone knows where this 5050 is coming from. When we started the Mesos, we looked at that, it's running in the 5050 thing. Now, finally what we have to do is that we have to create an instance of Mesos scheduler driver. So the name is very interesting. What it says, it is a Mesos scheduler which will going to run your driver. Okay, so that's the kind of a name. If you go a little bit right, it takes actually 3 parameters. It takes your scheduler, which is the scheduler you want to run, that is my Scala scheduler. It takes this framework information, which means all this authentication, authorization, name, etc., etc. And finally, it takes the Mesos URL, which is the master this one. All are able to follow what's going on? So we created a framework where we have all the information. Then we created our instance of Scala scheduler, which actually implements our actual framework. Then what we did, then we given the Mesos URL, combinedly we created something called Mesos driver. And Mesos driver or Mesos scheduler driver, you think is something which actually launches the things. Very similar to what we have like Spark submit in the Spark, which actually takes your code and launches it. Very similar to that. Mesos schedule driver is kind of an entry point for the whole application. Then finally what we say driver.run. This actually follows very similar convention like thread. There are start and run. Run means just take over the main thread and start using it. If you say start, then you will get back the control, you can do something else. But I am doing a run, the reason is that it's simpler. But you can do a start and other things also. So what is the client does? Client does very simple thing. He creates a framework. it creates the instance of the scheduler, then it gets the Mesos URL, combinedly it gives it to the Mesos scheduler driver, which is the entry point for the Mesos itself, then we start to run that driver. Are you able to follow till here? Yes? Okay. Let us go back to the slide. So next question we will start asking is, what is a scheduler? Right? What is that Scala scheduler is? Now in the Mesos, every framework on top of Mesos has to implement this scheduler API. The reason it's called as a scheduler is, that the API is called a scheduler underneath. Right? Every framework which has to be implemented on top of Mesos has to implement this scheduler API. That's why our thing we are calling as a Scala scheduler. And scheduler is the entry point for our custom framework. Which means if you want to do any distribution, reading, writing, all those things, actually the entry point is your custom scheduler, which you extended from the scheduler system. So the analogy I am using is that it's very similar to Spark Contest. Spark Contest has some more stuff also, but it's very similar to idea that contest is an entry point everywhere. So it is kind of saying it's an entry point in the Mesos. Now, in the interface, there are a lot of different methods. Okay, so there are a lot of methods, but only one we are going to care as of now is called as resource offers. Okay, any idea what may be this resource offers? Everyone understand what is a resource? I think after Flipkart and Snapdeal came along, everyone understand what the offer is. Right? Any offers are going on as of now? We will talk about it in the team. Right. So what I'm trying to say is that it's an offer, but offer for what? Resource. So whenever you work on the scheduler level, what you actually only focus on? Resource offer. There are other few things, we will discuss about that later, but only we are concentrating on resource offer, which is very similar to application master API. So I'm not sure how many of you gone through the yarn. Oh, how many of you attended last meetup? How many of you seen the videos of last meetup? I think we have looked at few of the things, like we looked at the yarn API and how we do those kind of stuff. It is very similar to application master API of the yarn, where you have a scheduler which is called as application master, and from the application master I should ask for the containers. In the Mesos, those containers are actually resource offers. Makes sense till here? Okay, let's move on. Now, what is an offer? Offer is not a discount in Mesos. Right? Offer is more of saying, I want to offer you something. Okay, the word offer is used in the context of, I want to offer you something. This offer you what? A resource. Now the question is, in a distributed system, what is a resource? Right? Resources can be a disk, memory or CPU, and newer version even the network. Okay, so by default what we think in terms of a distributed system, what are the things? We have a disk, we have a CPU, and we have a memory. So whenever there is a resource offer, the idea is that Mesos comes to you and say, see, in my system I have a 4 GB, 4 cores free. Are you interested? It's a reverse of yarn actually. In the yarn I should go and beg him, right? Give me something, right? So in the Mesos it's like a push model. The Mesos comes to you and say, are you interested in this offer? I can do two things. I can accept the offer and I can use it. Otherwise I say, don't worry. No one is submitting the job to me. In the yarn is reverse. You go to the master or the king and say, do you have any free resources? The resource manager said, no, go back. You come back to me after some time. So I have to keep on waiting, saying that, do I got it, etc., etc. So actually Mesos reverses it. You never come to me and ask, because I am annoyed from that. I will tell you when there is a resource. Till that you just keep quiet. Are you able to follow what is the resource model? So yarn follows this idea of pull, where we actually go and ask for the containers, and if it pleases it will give it to you, otherwise you have to keep on polling. But in the Mesos it's like a push model. Actually the resource manager or the Mesos master come to you and tells there is an offer for you.
So this is so the client registers that I want this much.
Yeah.
And then it will...
No, actually in the Mesos you don't even have to say how much I want it. So this is one thing about Mesos compared to yarn. In the Mesos it's like whenever there is something free, it keeps on offering to people. Thing is that I can reject it, so I say I don't care about it, I can accept it. The reason why it is like this is, it does a very good offer management in terms of multiple applications. Now what happens in the yarn case, or most of the time, is that one application is very greedy. What they do is that they say, I want 500 GB machine. Why? I just like to have it. Right? So what happens is that I take it and I will never give it back for a long, long time. Now in the Mesos, what happens is that 500 GB thing, it can keep on asking everyone, and at that point of time I can decide, do I have to use it or not. I don't have to upfront ask for something, because upfront I may not know how much I want. Initially I say I may want this much, but after some time, if you have more, tell me. I will look at, do I use it or not. This is like, how many of you use Ola cabs or Uber? It's like a Ola cab peak hour. Right, it's like, it keeps on telling you there is a car nearby. If you are the peak hour, it says you have to pay 2x. Right, but you say, I really want it, it will give it to you. Otherwise, if there are many cars, what will it keeps on showing those. Okay, there are more cars here, more cars here. Are you interested? Are you interested? The reason is that if I ask myself, like, when I want a car, I don't know. Maybe I want at 6:30, but my boss actually not in the happy mood. His or she is not letting me go. Maybe I want it at 7:30. So what happens is that we don't demand much upfront. You can have, you can do that demand. There is an API for that. But mostly what we say is that whenever there is an offer, let me know. If I have some work to do, I will take that offer, I will use it and give it back. Yeah.
So how do Mesos slaves know where to give the offer? For example, let's say Mesos master that we have, right?
Yeah.
Let's say it goes down. You have a secondary master. So how do they know where to advertise the information?
Oh, that's a good question. So the question was how a slave knows when there was a fault where to give the advertisement. That's actually done by the zookeeper. So in the zookeeper, we keep track of who is the master, and normally what happens is the distributed system, they always talk to zookeeper, and in the zookeeper they ask who is the master, and whatever the zookeeper says, they go to the master, and of course there's a caching in between. So which means if I ask like 20 times, if the same master is there, I will cache it, and the zookeeper library will make sure that you will clean the cache after some time. Right? You kind of say, oh, I tried, I failed, now I will go back to zookeeper and ask who is actually the master. So that's actually done by the zookeeper itself. Okay?
Do you see a clear-cut advantage of the two approaches? I don't see any actually.
Okay, so yeah, so that's a good question. The question is that, is there any clear-cut advantage to have a push model versus like a reverse model? The only the difference is that this polling mechanism of the application master can be reduced. Right, so because if you see most of the use cases today we work with, like actors or a lot of things, we are moving into a push model compared to pull model. The reason being is that this polling takes a lot of resources just to waiting. So that's why it is a bit better than other. Otherwise, the resource management looks much similar to yarn. So this is one of the difference between Mesos versus yarn. In the yarn, we have to ask for the resources and you have to wait. In the Mesos, it like advertises the offers, and actually any framework can take it. It's not like one framework has to take it. It keeps on asking. Whoever takes it, they start using it. So what a framework does, a framework accepts the task or accept the offer and it start using that offer. Offer means most of the time offer has few things. What are the things it has? It has actually this host name where the offer is available to you and how much resources are there. How many CPUs you have, how many disks you have, how many storage, etc., etc. You can look at that offer and say, oh, this is good enough for me. I can start using this in a given slave you ask for.
So is there any timeout mechanism? Let's say like, for example, my task is greedy, the example here, right? I have taken 500 GB when using Mesos and I don't want to give it back.
Yeah.
After some time, you as application master is like, annoyed, you just want to kill me.
Okay, so that is a good question. The question is that if you have greediness inside the code, actually there is no solution to it. So application master don't randomly kill it, or there is no time, because what happens is that sometimes it's very difficult to say is task is doing anything or not. Because it may be waiting for, let us say, in the MapReduce case, the reducer may be waiting for results to be came from a map. But if the Mesos says, okay, I will going to kill you, but that's going to create a problem. So the greediness inside the application, there is no way. Only thing is that if the application is built in a nice way, what they can do is that they can only take the offers when they like, rather than taking over the whole thing and upfront asking for too much. Because normally why application ask for too much? Because they don't know when they want how much. So they just say, give me like whatever you can. I will figure it out later. But that creates the bottlenecks when you have multiple applications running on the same cluster management. It was not a problem when you only had MapReduce. MapReduce only is the king, it runs and no one asks questions. But once you start doing multiple things, it becomes a bottleneck. So it is quite different than the yarn model. So the yarn model is more of a, yeah, question?
How is it ensured that the scheduler does not starve?
A scheduler?
So upfront it is not asking for any resource.
Yes.
So how is it ensured that at the end of the day it is offered indeed, what resources?
Okay, so that's a good question. The question is that if there are multiple applications, how to make sure that one application or one framework is not starved? The reason is that it uses round robin things, which means after it given the framework once, next time when there is an offer, actually it goes to another framework before it goes to the one which is given before. So it makes sure that everyone gets a fair share to say how many things, and also there is a ways to say how much do I want upfront, so it can even calculate. If this thing asks for a 10 and this asks for a 2, maybe if you have 3, maybe you give 1 to this and 1 to that. Those kind of fair scheduling, all those things are also very similar to yarn we have, right? We have fair scheduling, capacity scheduling, we do have those on Mesos also. So that ensures that one application is not kind of having a starving across the multiple days because it's not getting the enough resource. Okay, now before I get into the actual scheduler code, let us talk a little bit about the executor piece. Now, what is the executor? How many of you heard executor before? Not in Spark, somewhere else? In Java, there is something called executor service. Right? What is the executor service? It is a thread pool, right? So it's kind of a thread pool plus some more stuff. Now, what is the executor actually is? Executor is something which sets up the environment to run the tasks. Okay, in terms of Java, executor service is kind of a thread pool and those kind of things. In terms of Mesos, actually what is an executor? Executor is an environment where a given task can run. Very similar to Spark executor. What is a Spark executor? It's a JVM where some Spark code is running, there is ability to cache, etc., etc. So what is the executor does? Executor is an environment inside which you can run your tasks. Now you can implement your own executor, but we are not going to do in this example because there is a built-in one which actually can do command executions. Right? What it does is that there's a built-in executor. What it does, it can run any your operating system binaries. So you don't have to create a new executor from scratch. You can use the existing one, which is very, very similar to what yarn does. If you just want to run the shell script, you don't have to come up with a complex logic because it can run the shell script if you are on the Linux operating system, etc., etc. So what we are doing is, what is an executor? Executor is an environment in which the given task runs. Normally environment means if you are running a Java code, it may be a Java JVM, etc. And if you are running a shell script, it may be an operating system. If you are running a C++ code, it can be something altogether different. And one more thing you have to remember is that in Mesos, unless you ask for it, it's not a JVM. Okay, so this is also another difference. Unless you ask for it, which means we will see one of the example is, where is my executor is going to be some Java code to be executed, then only it's going to be JVM. When you run your shell script, it's actually running in the normal operating system process, which is different in yarn. In yarn, everything has to run from the JVM itself because the containers internally are JVMs, not your operating system process. Are you able to see what is the difference? The reason again is simple because Mesos is implemented in C++ and they really don't care about Java, right? You can run C++ code, Java code, whatever the different kind of framework you like, and it gives you the abstraction. Okay, next. Now, finally, what is a task? Task, I already talked about this abstraction of resources, and a given task actually has these 4 information. So when we create a task, these are the 4 information. One is task ID. So I think you have seen this task IDs in Spark and Hadoop also. Every task what you create, normally it's a job ID underscore some other information. I think, how many of you seen that in the UI? Right, job ID underscore something. Okay, so that is the task ID. And offer. What is the offer? Every task has to say how much resources it wants. And where it gets from the offer. There was an offer, I took the offer, and task should say, this is the offer I want to use. Think like the gift cards what you gift, right? Like if you go to a place and say, I have a gift card, you have to show a gift card. And then only you say how much you have in the gift card. Similarly, when the task want to run, it has to tell to the Mesos that which offer it's using. If there is no offer, task cannot run because there are no resources allocated for the task.
So how Mesos upfront knows what to offer?
Sorry?
How Mesos upfront knows what to offer to a task?
Okay, that's a good question. Actually, Mesos offers whatever is available. Task can take some portion of it. So offer may not need to be completely taken. It can say, I have 4 cores and 10 GB. The task can say, I need 1 core and let's say 3 GB. Then what? So what is left? There is left 3 cores and some more GB. It can offer to other frameworks or other tasks. So task actually says, in the given offer, how much I want, and only that is given. So it is up to the task to say how much I want. Mesos only says, this is available in the cluster. How much you want, you decide.
And offers can be made parallel as well, right?
Yeah, you can offer, yeah. So there can be multiple offers at a time. We can take multiple offers at a time also. Third thing is that it has to tell which is the executor is going to run. The reason is that it has to tell what is the environment it's going to use, because different tasks can use different environments also. Maybe there is a shell script which don't need a JVM, but there may be a Java code which needs a JVM. Maybe you have another code which needs a Docker. You can create what kind of executor you like. So it has to tell which is the executor, and also it should tell slave ID. What is a slave ID? It should tell which machine I want to run. Actually, that comes from the offer itself. You can look at the offer, and when you say offer, it actually even specifies on which machine those resources are available to you. And when you create a task, you have to tell to the Mesos that I want to run on this machine. Now the reason this option is there is for another reason. In Hadoop, we have this data locality idea. Everyone knows what is the data locality? I want to run on a machine where the data exists. Now when you run the Hadoop or Spark on top of Mesos, sometimes what they do is that they only take the offers where the slave ID is the one which they want to run. They may have a machine which has the resources, but they may not want to take it because they want to create the data locality where they can say to the Mesos that you have to run this in this slave only, because I will get that data locality. If you run somewhere else, then I don't get the data locality. So which means there are cases inside the framework where they can say, even if I have an offer, I want to decline now because I want to run on a machine where there is a actually data locality.
So
Yeah.
Will it wait until it gets the resource?
Sorry?
So will it wait until it gets the resource? From
Yeah, sometime it will wait for some time till it gets the resource. Yes.
So yeah. So when you say offer, right?
Yeah.
So, like in some case where you are running say multiple slaves, right? Kind of scenario. Say one slave has like 4 cores, another slave has another say 2 cores, 3 kind of thing. Does the offer, give you an aggregation of that, or it will be still like 2 offers?
Okay, that's a good question. So if you have multiple machines, then it's a multiple offers.
Okay.
Because
So
inside
per-
offer, yeah,
per slave.
per slave you know what is an offer. So the reason is that so that you can segregate, right? So, but when you get the offers, you get all the offers you want to, whatever is free, but within an offer, you know which machine you are talking about.
So you'll have to break it into multiple tasks, let's say, right?
Yes.
You need to.
Correct. Then you can get the, okay, you can even use the one machine to run the multiple tasks. It's like having a multiple JVMs running, or you can even decide, I want to take 2 different offers, I want to run one here and one there. So the granularity of the offers are, they come up with which machine has this resources also. So if you have multiple machines, you will have multiple offers flowing in where you can say, I can write, because sometimes what Spark does is that it says, there may be next offer which may have that the one machine which I like. This offer I want to decline. Now the question is that what happens to the declined offer? Actually it will be given to you after some time. It's not like it's lost forever. It will be not given to you for some time. After some time there are some timing, it will be given to you again. If you like it, again you can say, oh, I never got that offer where I want to run on this machine. Now let me run on this machine. Those statistics actually framework can keep track of, so that I know what I have seen earlier and what I want to do in the future. Yeah.
How are we restricting the execution of the application on a machine? Is it through the ID?
Yes. When I take an offer, I know the slave ID. Then we are restricting, if I say slave ID.
Is something randomly generated? Is there something which is given in a machine?
No, this slave ID is generated by the Mesos itself. This is not the host name of the machine or something. This is like given by the Mesos itself.
So, for example, if you want to execute something on a machine which has already this application, for example, it's Java.
Okay.
You're saying you are having this specific application. How do you identify that?
Oh, that's a good question. That's a good question. The question is that what if you have a cluster which is heterogeneous, right? That is not there in the scheduler level. There are multiple ways to do it. For example, people do something called node labeling. So what is the node labeling? Is the idea is that you label the different nodes saying that this is for Java, this is for that, and in the actually Yarn there is a way to say label. I am not exactly know how you do it in Mesos, but that option is there. So you can tell when you create a cluster that these are the nodes for this one. And when you start an application, you can specify that, use only these nodes, don't use others. So actually you can partition the cluster for different applications also. Yeah, that option is there, but not there in the code, but in the configuration we can tell those information. Okay, that's a good question. Any other questions? Yeah.
So about the data locality, right?
Yeah.
Since the data is stored in HDFS, how
Yeah.
do you know which specific machine it is stored?
That is application part, right? The Spark goes to the HDFS API and asks where is the data is. So Mesos don't know about it. Mesos only says in this machine the data, in this machine do you like to run. Now application goes to HDFS and asks which machine you are on. Then it tries to think. Now one of the things is that I only told you the slave ID. That is a unique ID. But there is one object called slave which has the host name and other information also. When you tell to the Mesos, you have to tell the ID, but there is a way to correlate the offer and the slave on which I want to roll. So what application does, it goes to the HDFS API and asks, where is this data? It gives you the list of host names, and then it looks the offer, it tries to match. Do you have a machine where there is an offer and there is a data? Right.
One more question.
Yeah.
So when like a slave uses specific offer, let's say like I have 3 GB and say 20 GB of
Yeah.
hard disk space. So does that mean it's a strict offer? Like it's like system can take it back when it's required.
Yes.
Let's say like I as a slave, right? I have given like 80% of my spaces,
Yeah.
and later I realize like for my own system processes I need more data.
Yeah.
So can I take it back?
That's a good question. Normally what you do is that you get out of memory if you are trying to use more, but it will not try to kill the task unless there is some problem. So the slave will not try to take over. And this is the difference between Yarn and Mesos again. In the Yarn there is an overhead called as 1 GB overhead. So if you have done Spark on Yarn, normally we configure an overhead space because it runs a JVM and Yarn needs some space, and inside that Spark Executor runs. But in the Mesos it's very lightweight. It's a process where only Executor runs. Actually the Mesos do not need to run anything else. So actually when you say 2 GB, the whole 2 GB is given to you. The Mesos do not take anything else. Mesos has other pieces which is running outside of the thing, and when you get a resource offer, it's after it knows how much it needs itself, then it gives you the offer, not the ones which are there. But it is not true in the Yarn, because when you run in the Yarn, you are running a JVM for a container and it runs some of the things. It needs some of the space inside a container itself. But Mesos don't need anything inside the container. All are able to follow till here what is the offer and what is the task. So task is a place where we can say which slave I want to run on and how much resources I am going to use. Okay? Next. So what we want to do is that now we want to go back to our scheduler example and see what was that Scala scheduler. Okay. Let us open the Scala scheduler. Yeah. Now the Scala scheduler extends scheduler. So what we are going to do is that there is an API called scheduler. We are going to extend from that. And if you see, since it is an interface, we have to override a lot of stuff, but we don't use it. Right, let me go through the functions very high level. We are not going to use most of them. For example, the task is our own stuff. This is nothing to do with the things because it's a variable task, it's a class variable we are keeping. Now what is the error maybe? What's the error? If there is an error in the application, it's a callback. Now Mesos works with the idea of callbacks. So that's why I'm saying the push model. Right? So you register the callbacks for the Mesos, and whenever something happens, you get a callback, and inside a callback you can do whatever you want. And the whole API is built on top of the callbacks. So what you do, there is a callback for error, and there is a callback for executor lost. Which means one of your executor is lost, do you want to relaunch, do you want to do this, you can implement in this API. And what is a slave lost? So slave lost is that not only executor, the one machine completely went down. Now what you can do, the application can reschedule some of the things in other thing. So those kind of options you have. what is disconnected? So the disconnected is you have disconnected from the whole cluster itself. So then what it can do, it can retry, because for example, Mesos master went down. Now what you get? You get back one callback saying that you are disconnected now. So you can intelligently reconnect, no need of restart or those kind of things. The reason why the option is there is for streaming. Right? When we do a Spark streaming, I don't want to go down because my one of the master go down. I want to wait after another master comes along. I want to reconnect and go from there rather than have to go down. Okay? Which is not really true in the yarn. In the yarn, if the resource manager goes down, there is no way to reconnect back. Right? That application master don't have an API. It's the application work to do that. It can wait or it can just wait for some time and give up. But here, actually, you can say disconnected, what to be done. And there is something called framework message. Actually, framework can send some of the messages. For example, this is where you have this. If you come down a little bit. So what is the framework message is? This is the message API. What is the framework message is? This is a message which is going through your own framework. Let us say your slave is there or your executor is there. It can send a message that I have done it. Then you get it in the framework message. And if you go a little bit right, let us see what is the framework message, because we are going to use after some time. You see, it will tell you which is the driver we are talking about. And if you see, it talks about executor ID, which means it is an API to communicate between executor and scheduler. Are you able to follow? This is the API I was talking about. The framework message means this is a messaging API which is built in for a custom frameworks, where an executor can send a message saying that maybe sometime what, maybe I am done now, right? My tasks are done. That's the one kind of message. Second thing, maybe if you are doing, let us say in Spark, you are doing collect API, right? So in the collect API, what happens? You read the data from HDFS and sending the data itself. The message can even have that data. So Mesos' idea is they have built-in API for message passing between executors and drivers, and of course you can define how to handle the messages. That's up to the framework, but there is a messaging facility, which is as of now not there in the yarn. In the yarn, you have to use your own things like Akka or something else to do the message passing, because it is not built into the API itself. Again, we are not going to use all this as of now, but as we go along, we are going to use some of the APIs. If you come down a little bit. Okay, so there is something also called as status update. The difference between a status update and framework message are, status update is more of task completed. Right? It's more of saying, is it completed or is it killed, all those kind of things. Framework message is more of what is the response of that task. So that's kind of a differentiation. So as of now, what we are done, we are just printing it. Received status update. We are not doing much. We are just printing the stuff. And okay, what is offer? Okay, I forgot how to read this. Listen there. So it's more of saying, once you get an offer, there are multiple states it goes to. Is it a re-offered offer? Or is it something you rejected, it is coming back now? Or is it something you want to go back or give back, those kind of things? So there are some callbacks. We are not going to discuss much because even I forgot what was that. So the whole logic mostly sits in the receive offers. Okay, so yeah, sorry, resource offers. So most of the logic sits at the resource offers. And what is the resource offer takes? It takes the scheduler driver and offers. And what is the offer? It is a offers, which means a list of offers. Okay, at a time you can get multiple offers and it's up to you what to be done. Now inside this code we implement our logic. Okay, so resource offer is the one method which we want to concentrate on. Let us see what we are going to do here. Now, in this example, we first say, look at the offers, and the API is Java, so that's why I'm converting it to Scala API. And if you see, this code is written when I was learning Scala. That's why the for loop is there. But now I know I can use for each and other pieces. But I have not even thought of rewriting after I was doing for a thing. So it is still a for loop because I loved for loop back then. So what I did was, I took a offers and I look at the offer. And I don't have any logic saying that should I use offer or not. In this example, I'm very greedy. If you have an offer, I'm going to use it. I don't care how much you have. I don't care is it really needed, this kind of thing. If you have an offer, I'm going to use it. But till when? Till I have number of tasks are done. Which means what I'm doing is that I have given 4 commands. I am going to consume 4 offers because I want to run 4, but once I am done, I am not going to consume any more. Are you able to follow? That is the logic I am following. There is no other logic is done here as of now. Is that there is no concept of slave ID, should I go there or not, those kind of things. And as I told you in my initial requirement, I am not considering the data pieces of it. I am only concentrating on the process piece where I am not going to concentrate about data locality and those kind of stuff. So I am not considering that. That's why any offer is good enough for me. So if you come down, so what I am doing, take the task and dequeue, which means I am using a queue to get the task. And we say value equal to true because when you give the dequeue, you have to say, do you want to or not? So the API is that it asks for a filter option. I say I don't care, give me all the tasks. And then I start doing map. So what is that map has is that it has this command string. Each task is actually a command string. You can say echo this or you can say sh this. So different things. So it's just a command what I want to do. Now what I want to do is that I want to take this string of command and convert into a task. Are you going to follow what we want to do? We want to take this string and I want to convert into a task because I can submit those tasks into a Mesos. So that's what I'm trying to do. I want to take the string, I want to convert it to a task. How I do? The first thing is that there is something called command info. Again, if you see, this is a similar, builder factory kind of idea, right? So you say command info, and in that there is something called command string. So this command is way of saying whatever the executor was. So the executor here I'm using something called command info, which is underneath uses command executor. It can take any string and run it on the operating system. That is the first step I do. The second step I do is that you have to tell what is the resource you want to use. I say I don't care about memory and disk as of now, because my code is not disk intensive or memory intensive, but I need a CPU. Can you run command without a CPU? No, you have to have a CPU, but CPU cannot say give me CPU. There has to be some way of telling it. So what I say I want a CPU, and CPU is a scalar value. So in the Mesos, there are ideas of the scalar values are nested values, because some of the things you can be nested also. What I am saying is that it is a scalar value, and what is the type of resource I want to use? The API is called as resource, and in the name I have to say what is the resource name. Is it a disk, is it a memory, is it a network, or whatever it is. I am saying it is a CPUs, and if you go completely to the right, I have to say how many CPUs I want. Now the reason why this code is not so nice because of the Java API piece. Java people like setters and getters, so that's why we have to keep on writing it. So that's why the Twitter went ahead and created their own API for Scala. But since we are in the Java world, you have to say I am Apache Mesos, new builder, set value. Right? In Scala you can say underscore 1.0, you are done. So what we are doing is that we are saying we want the CPUs and we want the one CPU. Right? If you have one CPU, I am happy. Then what I am saying, actually there is even to say resource, which is the role I am using, because you can do partitioning of the resources based on the roles. Right? You can have a super framework role, which is dedicated resources, and if you are a part of the super framework, then only you get those resources. Otherwise, you will not get those resources. So those kind of role management within the frameworks is also possible, but I say don't care. And finally, we will create a build. So, of course, because of the builder factory, it takes a time to say, I want a one CPU. It takes like 4 lines of code, right? So, then what I say, I need a task ID, which is kind of unique, right? In the Mesos, across the framework, the task ID has to be unique. And how you get a unique, there are so many ways. I am just creating a milliseconds. You can use UID, and I don't have a concept of job as of now. It's just a task I want to run. Finally, how I create a task? I say task, create a task, and give this command, whatever the command string I created. Then set a name. Okay, in my example, I'm using name and ID same because I don't care about the task names. And set task ID again. This builder pattern will come along because each of these methods takes a model, and these models are a protocol buffer underneath. And how to create a model using a builder factory. It's very similar to saying new task info, but if there is no new, what do you have to say? Take that object dot new builder and do the stuff. Okay, and add resources. which resources I want? I want those CPUs, slave offer. If you see, slave ID, offer dot get slave ID. So I can get the slave ID from the offer itself, and finally I'll say build, and if you come down a little bit, and how I launch it, driver dot launch task. This is now deprecated, but I have not cared about that. Offer dot get ID. Now for a given offer, there is an ID. I have to tell which offer I'm going to use, and you can give the list of tasks. Again, you have to convert back to Java because it expects a Java list. So what I have done is that I took a Java API, wrote everything in the Scala, and before I go to Mesos, I will convert it to Java so that it will not be unhappy. Right, so what we are doing is that we took a command string. For each string, I am taking the offer, and for that offer, from the offer I am saying how many CPUs I want. And if you look at it, do I even look at offer, do I have the CPUs or not? No, that's a simplified version. I am just saying, give me one CPU. The reason is that I thought if you give an offer, there should be one CPU. But if I am asking for 4 CPUs, it's good to look at the offer and say, do you actually have 4 CPUs or not? Otherwise, if you give an offer and say a task, you cannot run now. Because offer says 3 CPUs and you are asking for 4 CPUs. But here, since it's a simplified version, what I'm saying, don't care, I want one CPU, just give it to me. Now you created a CPU, that's a resource, and you created the command string. Then what you do, you create a task which has the both resource, executor, and the slave ID. And finally what you do, you say driver dot launch task, offer dot get ID, and the listings. This is the way to submit to the Mesos.
Are these offers given in parallel to many applications, or is it, can you get a fail asking for an offer? So if it is given in parallel to many applications?
No. It's once an offer it will be given to one framework at a time. Because if you given to parallelly, someone may take it, and I also took it, then I'm starting use. So whatever the offers is given to you, and you take it how much you want, then whatever is left, it will be given to another framework.
And you said it's done round robin, right?
It's a round robin,
so
yeah.
The entire process could be, if it's done over the network, the next time you get an offer, it will be quite some latency.
Yes, that is actually it's actually created in the framework such a way that you don't have a starving stuff. So normally what the framework normally does, you have a list of offers, right? You take as much as you need in the first code. So that option is also there. For example, list of offers means you may have like 4 machines, you may get all the 4 things. You don't have to take one by one, you can give me all the 4 because it's a list of offers. Otherwise you can say, as of now 3 is good for me. I can wait for one more when you come back later. So it is done for intentionally because there is no starving for the frameworks. Because Mesos is created for multiple frameworks. They don't want one framework getting hit because other frameworks are getting greedy and it's taking over every time. They want to make sure that every framework gets a fair chance.
So once an offer is given to you, how much time it waits?
You have to give it back, or you have to be killed. There is only 2 options. Which means you have to go down, or you have to give it back.
For how much?
There is no time limit.
So I can just keep it infinite, right?
Yeah. Then the user who is running that framework will stop running that framework.
Okay.
Right. So that's the user call, but there is no limit inside the Mesos saying that you have to give, because you don't know what kind of processing you are running.
Okay. Yeah.
Right. Let us say I am running streaming. So for example, in sparse streaming, we keep on those executors forever. So if you run the Mesos and sparse streaming, it cannot say give me back because I want it for how much time? Forever. So there is no option like that. Yeah.
Yeah, thank you.
Yeah.
Here we're talking about CPUs.
Yes.
So how can we use CPU and memory from 2 different machines? Can we mostly link each other?
That's a good question.
Second thing is,
yeah.
if we have a dependency on your CPU architecture, for example, my application needs to run on an x86 and another one needs to run on probably a 32-bit or 86. So
Okay.
how can that be?
Those are good questions. The first question is that can we mix and match disk and CPU from different machines? As far as I know, no. Because offers are always granular level is the machine level, and if you say I want this much of this, and disk is not distributed here. So we are not thinking about disk. These offers are not for HDFS. This offer for a specific disk, and when you take an offer, you are saying I want to use a disk inside that machine. But if you want to have a distributed, then you have to go with HDFS. You cannot do it with the Mesos. That's the one thing. The second question was 32-bit versus 64-bit. That's where you can use the slave IDs. But that you have to know, I think, upfront. Which machine has a 32-bit and which machine has a 64-bit. Then in the offer, you know which slave you are talking about. On top of that, you can decide. But Mesos itself, I am not sure, do they expose those information to you? Like, is the offer contains 32-bit or 64-bit, those kind of stuff.
Slave object is there. Can we populate any value in slave object, or we can just use that?
Where is the slave object?
You said once that there is a slave object also. You can get information about this.
Oh, okay. So that's a good thing. I think offer.getSlaveID is one of the options. There is some more information. And as far as now, I don't know what is the information it's keeping. Inside a slave, my understanding is that it only keeps the resources and the host names. But I'm not sure, do they keep architecture, OS name, and those kind of things. You can explore that, what are the information they are storing there.
So if they have some description or something, we can dump those values there.
Yeah, so most of the idea is that you can look at the slave information and try to find out is the machine you want to go. Maybe the information comes from your lookups, or maybe you have maybe it says it's a Linux machine, or it says Linux 32-bit. You can look at those information and say, I want to decide. Okay.
So Madhukara,
Yeah.
you said that it's sequentially going through all the processes. So,
Yeah.
imagine a case where the job is doing too much analysis. It goes back to the Hadoop API, asks whether what it does all the mix and match. So what's the timeout? Like, is it a configurable value?
What is after how much time it retries?
After how much time it says that, okay, I have given you this offer, but you haven't accepted it, so I'll move on to someone.
Okay, so that's a good question. The question is that in the offer, there are only two possibilities. You have to accept it or you have to reject it. So when you get an offer, actually there is no option to say, I don't know what to do. You have to explicitly reject that offer, otherwise it will be never offered to you again. So the idea is that we'll see in other examples that this is something actually took time for even me to understand. What used to happen is that an offer came to me. I didn't do anything, I didn't take it. It never came back to me. Because I should have rejected explicitly that. The rejection means I'm saying as of now, don't want. But after some time I may want it. But if you look at the offer and don't do anything, it will not be given back to you.
So it's accept, reject, and timeout, in which case it won't be offered.
Yes. 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 Unable to follow what I'm trying to say? You have to look at the offer and you have to explicitly say, I reject it. Otherwise, because what happens is that how Mesos knows which offers the applications are interested. Otherwise, it keeps on giving you the same stuff. If you're ignoring means it's like, let us say some person is coming to you and talking to you. What is the clues you give? That I don't care. Initially you talk and say, okay, you are great, etc., etc. After some time you start ignoring people. Why? Because you don't want that offer. Right? It's like people from credit card company and calling you, right? I don't want the credit card. Then they will not call. Otherwise, you will be in the round robin thing. Right? So they will go through the list and say, okay, let's start from the beginning.
No, so they'll call you when you reject the offer.
Right, okay. So they don't follow the Mesos things, right? So Mesos is good guy. It only want to sell offers if you are interested. Otherwise they say, okay, there will be another framework to whom I'm going to
But it
sell.
doesn't mark you as dead, right?
No, it's not much. Only for that offer, it will not re-offer. See, there are multiple offers. I can reject some of the offers, which means I'm interested, but not now. Some of the offers I can ignore. That means that I don't care. Don't give me those offers. Give it to someone else. So inside offers, I can say which is the one I'm interested in and which is the one that I'm not really interested in.
So rejection doesn't say that you're not interested, just or
As of now. So rejection means as of now, I am not interested. So one of the easy ways of saying that, let us say you propose someone or you get proposed. So normally rejection means as of now I am not sure. Right? Later there is a possibility. That's how it happens in the movies, right? If you get proposed and immediately the movie is done in half an hour, then you have to go through the whole loop to make sure that you say yes. So that kind of an indication that there is an interest, but as of now it's no. But in the ignoring means I don't care. So ignoring means any point of time you come, there is no possibility going to happen. Right? So that's kind of an easy way to remember. You should reject it, otherwise there is like always confusion. Is a rejection or not? It's like ignore, is those kind of stuff. Anyway, so in the Mesos, what happens is that you have to reject the offer so that Mesos knows you are interested, and next time when you come, it will be at the offers. All are able to follow? And this is why this is a little bit different than the YAR model. YAR model is more of we ask, if they have, they will give it to you, and it will give back once you are done. There is actually, if one of the things about Yarn is, if there are more resources available, they will not tell you. You have to keep on asking them like, do you have it, do you have it, do you have it? And when they actually comes, you will give it to you. But if the resources are already available, there is no callback. Because in Java, there are very few APIs which follows the callback API idea. Right? There are only few APIs which have the callback. But in Scala and in Mesos, people like callbacks. For example, actors and those kind of things. You like callbacks so that the framework will tell you that when something is available or something is done, you want to do something about it. All are able to follow what is the Mesos model of scheduler. And if you come down, we have our own thing. So this was our own method. This is not our reading. So we had that submit task. Submit task, what it does, it just populates our variable. Right? Whatever the variable I want to read from. And it is actually, I think, concurrent thing, which means if multiple drivers are there, you can still handle it. And this is also important, this two option of registered and re-registered. For example, let us say you go to scheduler and it registered to the Mesos master. That is called as register. And you can do some init stuff. When you do first time registration, you can do some init stuff. And re-registered is that, okay, the master went down, it came back, now you are again registered. Now you can say, do I should do init or do I not? That is up to you. So that's why those callbacks are there. So idea of overall scheduler API is that it's a callback API. You just register what you want to do and Mesos will give you the messages depending upon the context. You look at those messages and you do something. And I think now everyone understand why there is a message passing API built in. Because when you have a callback, they need to have anyway the message passing. And what it told is that you can use for your own framework also. But whenever there is no push or there is only pull, there is no incentive to have a message passing. Because anyway, framework is not telling anything. You have to ask, and if it knows something, it will tell you. If it's not something, it says, I don't know, ask. All are able to follow, build this thing? Okay. Now let's go back to the slides. Okay, so let us recap what we have discussed. We have discussed about scheduler, we have discussed about client, task, etc., etc. And in the scheduler, we talked about the resource offers, right? Given offer, what you can do with it. Now, after doing everything, now we want to run and see, is it really going to run? So the way you run the Mesos application is very simple. You say Java CP, because this is our Java code we are to run. And you say which is the Java. I am using SPT for dependency management. Most of our earlier code we used to use Maven. Just for fun, I started to use SPT because in other projects also I am using SPT. You compile it, you get a jar. So what you are saying is that CP give that jar. Then you have to add these Mesos things also. For example, what happens is that the Mesos code is C++ code, and the way you ship the C++ code is this SO object. Right? Shared object. That is like a shared library which is similar to DLLs on your Windows machine. So you have to say, where is this SO file? So what I'm saying is that we have a Mesos home. Mesos home is where we had that bin. Inside there is a src and inside there is a libs thing. So whatever the SO files in that libs, just add it. That's the way we have access to the Mesos API. Right? So when you want to use Mesos API, we can put an API dependency, but this SO file has the Mesos implementation which I want to use. So that is the thing. And this class is my main class where actually the client is situated, and this is the one I want to run. So what I want to run is that I want to run echo command which echoes hello. And number of workers as of now we have one, but if you have multiple workers, each of these workers it will run hello. All right, to follow how we are running. We are giving a jar. We are telling this is where the Mesos libraries are. Take it from there and run this exam. Let us go back to the our command line and go to another tab. Go to our code. So just say cd. Just enter. Enter. Yeah, cd dev / my build. It should be distributed, D capital, I, yeah, enter, control L. So ls, just see something. Now, let us see, do we set that Mesos home? I'm not sure, just say echo $Mesos home, all capital. It will, yeah, it is not there. Okay, we have to say export. Actually it will not work sometime like this. Just say ls. We have to give the complete path actually. ls. Don't give just ls and give enter. Don't give enter. ls space. I want to say where is that Mesos? Slash home. Slash Madhu. And we have to say slash. Yeah, it is there in the dev, the capital dev, and slash Mesos. Yeah, there are too many. Mesos slash Mesos 0.25 slash build. So this is the path of my Mesos installation. What I want to do is that enter. Just copy that and export as a Mesos code. So which means when you run the Mesos application, it's true with the Spark application on Mesos also. You have to tell where the Mesos is installed, where those .so files are installed. Okay, I think we have set. Okay, so Control L and try to run that command. I think we can copy paste. Yeah. Okay, we have a new line column. Just copy one by one. Say control here. Just clean up the stuff and no, it will not work in that way. You have to open editor and copy it. Open a gedit somewhere. Open another tab. Yeah. Just open another tab. Yeah. Just paste that thing. So if you export your PPT as a PDF, it's strangely we have a new line issues, right? If someone has the answer, you tell me what to be done. Okay, so yes, it's the same thing. Let us hope that we don't have that column now. Enter. What is this trying to say? Okay. Distributed from the PPT is wrong. Okay. Go to README. So I think I have not updated PPT. Yeah. Go to README. Go to IntelliJ. Just open README. Alt 1. Yeah. This should be a README. Okay, so just copy this one. Yeah, this should work. Goes to preview. When you go to preview, copy the word. I think my jar name is wrong. So initially I was trying to do without assembly. Without assembly, it will not find the Scala and those kind of stuff. So it needs that. So yeah, we don't have to copy here actually. So it should work as nice. Control L. Let's do Control L. Enter. Okay, finally we are able to run. Let us see, is it ran or not? It's very difficult to understand. What we are printing here is that status of the offer, because you know we had a printing. Now what I want to go back to is that go back to UI and refresh. And if you see, do you see this completed task? Right, it says active task, there is nothing running. Now how I know that there is something ran or not? Just go to the right and click on sandbox. In the sandbox, actually you can look at the std error or std out. So let us open the std out. And do you see this? Right, so it is able to run the hello. Now how many workers I have? I have only one worker, that's why there is only one task. If you have multiple workers, there will be like multiple tasks you ran and you get a different things. Okay, so this is the way to compile your code and run on the Mesos. And of course there are, yeah.
Can you run multiple workers in the same machine?
You can. You can. So the reason is that when I start a worker in the Mesos, I can tell how many cores you should access. So I can say for a worker there's one core. If I have 4 cores, you can start 4 workers also. So those options is there. And I have given the link in the slides in the end how to do that. Okay. Any other questions? Yeah.
Let's say you have 4 slaves.
Yeah.
How do you make sure that all runs on all slaves?
That's a good question. So what we are doing in the earlier example was we are taking an offer and running one task at a time. But what you can do is that take all the offers, just create 4 tasks and run it.
To keep track of each slave I know.
No. You just take all the offers because you know I want to take all the workers, take all the offers and just run the same task on everything. You just have to set a new slave ID every time you run the task. So because if you see, submit task was a list of tasks. I can create multiple tasks for different slaves and I keep on setting. Yeah. Are you able to follow what you were trying to do? Actually, you can run multiple shell commands also. It's separated by space. You can say echo. You can do whatever the Linux gives. Are you able to follow till this point of time? And I thought if there was experience sharing, I will stop here. Okay, but there is no experience sharing. So what I'm going to share is my experience of doing next framework. Okay, so there is no Spark experience sharing, so we'll continue on the same experience. Okay, let us move on. Now the thing is that running the shell command is great, but mostly we don't want to run shell commands. Right? Normally what we want to do, we want to run some specific application code, and in our example we want to run some Java or Scala. Are you able to follow what I'm trying to say? In that case, you have to write your own custom executor. Why? Because you have to set up an environment, you have to create a JVM where you set up everything inside what you can run your code. Are you able to follow what you are trying to say? What is a custom executor? What if you want to run some custom code which is not a normal shell script, let us say Java or Scala code. The thing is that you can create your own executor. This is the way Mesos allows you to do different kind of frameworks. Right? You can have a framework which runs a C++ code where it can have a C++ executor. You can have a Java code which has a Java executor, which means every application on top of Mesos, it can define its own kind of executor which is capable of running whatever you like. In the break I was talking to someone that there is already one project which runs Yarn on top of Mesos. And that's possible because it thinks Yarn is one of the applications. Right? So Mesos is kind of a purely like operating system. It gives you an option to say whatever the things you like to do, just do it. There's no restriction that you have to do Java only, you have to do C++. Whatever the things, if you are able to create an executor on which you have to run, just do it. So what we are going to do is that, in the next example, we are going to create our own executor which actually capable of running some Scala or Java code. Are you able to follow what we are trying to do? Now the question is, what we want to run? Right? What do we want to run? Now there are different ways of doing. Maybe you say give some class you want to run, or you can create some interface you want to run. But what I want to do in this example or in this framework is, I want to run any given Scala function. Are you able to follow what I'm trying to say? My abstraction layer for this framework is any Scala function, if you give it, I should be able to run. Okay, so that's what we call it as a function API. Next. So what is a function task API? The idea is that as we have RDD in the Spark, my abstraction is a Scala function. Right? You can take any Scala function you like, you should be able to give this framework and say run. Now the Scala function may be doing maybe MapReduce, the Scala function may be doing something else, whatever it is. It do not matter to us. You can take any Scala function you like, you should be able to submit. So the reason why it is done in this way is, the initial implementation of RDD uses the same ideas. The initial implementation of RDD concept, we are using the Scala function level. Then only the job and other things came along. Are you able to follow why I want to emulate this piece? Why I want to say any Scala function we want to run? Because initial implementation of RDD was take any RDD function, create a function for in Scala and run it. There was no concept of jobs or multiple jobs or DAG or something. Because that's very simple to do. So what do you want to do? We want to take any Scala function and do it. Now the question is that if I have a Scala function, I should be able to serialize it. Why? Unless you are able to serialize it, you will be not able to ship over the network and run on another machine. But we don't have that problem because in Scala, a function is an object. Are you able to follow what I'm trying to say? In Scala, function is an object. If it is an object, I can wrap inside a serializable and ship it. Are you able to follow why function we are taking it as abstraction? Because it's very nice to express my calculations, and also I know that function is an object. If it is an object, I can wrap inside something called as serializable, and if I have a serializable, I can ship over the network. And the reason why it is like that, because that's what they used to do. This is the reason why in the Spark, Java serialization was default. Because underneath, initially they were using Java serialization, take a function, serialize it, and give it to the Mesos to execute. All are able to follow what I'm trying to say? Now, let us see our abstraction. We created an abstraction called task. Now, go to code. Open task thing, control shift can.
Here you're talking about SCADA.
Yeah.
API, right?
Yeah.
So how would if you're using something like a Python? So do you do any workaround like that?
Yeah, so this code will not run work for Python, because all the things what we are doing is that, if you will see in the later part, the executor will set up a JVM. It will not set up a normal process, because we want to run the Scala code. But if you want to run the Python, you have to create a process which runs actually that Python process, which can able to run your code. Yeah. Are you able to follow? Yeah.
So right now it's PySpark.
Yeah.
So basically they run a separate process and not JVM. Like what I thought is what they are doing is they convert the Python functions to actually something like Spark functions internally, and then serialize it and send it to the worker.
That's a good question. In the RDD level, the Python actually runs as a different process. And in the JVM and Python process, there's a communication. And in the Python, actually if you see PySpark architecture, there are two contexts. One is called as Python context, which is actually for Python, which communicates to actually Java Spark context. And in the worker, there is a JVM, and it's kind of spins off a Python process, which actually does your whatever the actual serialization. There is no conversion in between. The reason is that you cannot take any random code of Python and convert it to Spark or Scala. But if you are in the data frame level, it's different. If you are writing data frame in Python, internally it's a Scala code running. There is no Python process. So that is the difference between RDD and data frame. If you are in the data frame and doing Python, underneath it's a Scala code. But if you are doing RDD and Python, underneath actually there is one Python process running, which actually doing the most of those calculations. And what does the JVM does? It does this splitting and those kind of stuff.
So then it means basically Python, now there are two processes, so
Yes.
there will be communication between them. So that there will be some time delay also.
Yes, Python. So normally Python is like 2x or 3x slower than Scala in Spark. So that's a known thing. So if you see the graphs, Python is like a 2x, 3x slower because there is a lot of overhead. Are you able to follow? Any other questions? Okay. So what we are trying to say is that, let me show you like what is my API. I don't have RDD. I have a very simple API. I have an API called as task, which is of a trade, and it extends the serialization, because I will be able to send this task into any of the things I like. And the task has one method called run. Okay? And what is this T? T is the return type of a task. The reason why I have a T is that in the future sessions I want to implement this collect kind of API, where the task does something and it can give me the results. And these APIs are copy pasted from the Spark code itself. The Spark initial version, this is the API they had. So what we have? We have a T, which is like a type of the task. And I have one special kind of a task, which is called as a function task. Are you able to follow what I'm trying to say? The task is like a very high level abstraction, where I say there is a task and T, which is a return type of the task, and it has a method called run. And inside, in the hierarchy, I have a function, and it takes something, I'll come back to that, which extends the task of T. And what is that T? Now the T is the return type of the function itself. So when I have a function task, the return type of the function will be the return type of the task. Now the question is, anyone knows what is this syntax? Body colon. Any idea what is that? In Scala, they are called as lazily evaluated parameters. What I mean is that when I send a function to an object, I don't want to evaluate. I just want to get a reference to it. So the way we write is, given an object, colon and this one. And what is this? It says it is a function which don't take anything and returns T. So initially what we are doing is that we are trying to create a function which don't take anything and returns some type. Now what we do, our implementation is simple. Whenever the task calls a run, we just call the body of the function. Are you able to follow the API? I have a two-level API. One is the task. It says what is the task? It is something which has a run method. And what is a functional task? Functional task is something which takes a function as a parameter, and whenever I want to run the task, it will run the body of the function. Are you able to follow? The reason why it is done like this is that tomorrow I can have a task which is not functional. That kind of possibilities are there. That's why there is a segregation between what I want to get and what I want to do. Are you able to follow this API? Think like this is kind of a RDD, but I am not cared about the data part. I'm only talking about the functional part where I say, give me a function from Scala, I should be able to run it. Okay, let's move on. Next. The second part we are going to do is that, of course, we have to change our scheduler. Because our scheduler used to do this, create a command info and set the command, but no more we are taking the command, we are taking these functions. What it does, it creates this thing, and what it does is that it creates its own executor. Right? Because we can't use the default executor, it will actually has a different executor. And also, the question is how you send the data or how you send that function to a worker. Do you know how the MapReduce works, how they send the data or how they send the code? They actually copy the jar to HDFS and they copy it to the local system, then they look at the, your class. I'm not able to follow. In the MapReduce, what happens is that that jar will be shipped to the machine and you look at the class name and you load the class and run it. But problem with the MapReduce or most of the frameworks similar to that, they cannot do stateful operations. What I mean by stateful? Let us say I have a function which will say an example which has a closure. Now you cannot do in the class loading because class loading is always stateless. But in Spark we can do all those kind of things because I am shipping a function list rather than shipping a class. There is no class loading, there is no like saying load this class. This is saying take the function as it is, serialize it and deserialize and run. Are you able to follow? And why it is possible? Because in Scala, function is an object. If it's an object, I should be able to serialize it. Are you able to follow till here? So in the scheduler, what is the change? We are move away from the default executor because it don't know how to do it. The second thing what we are trying to do is that we want to send the serialized function as a data. Now one of the thing about task is I can send the data also part of the task. What I mean, when I create a task, not only I give all the information, I can say for this task, this is the data. Again that message passing API. And when I get the task in the worker node, I can look at the data and say, oh, this is the function I should run now. Are you able to follow? We want to communicate what function has to be run inside that task. How I can do? I can serialize the task and set into the task itself, which is called as set data. And whenever I get in the executor level, I take that from the data and execute. I don't need to use HDFS, jar copying, those kind of stuff. It can just do it there.
It has a similar to serial version UID which got gets generated in Java.
Yes, it's a Java serialization. Underneath it's a Java serialization. Yes. All are able to follow what we are trying to do? Let us look at our scheduler. What it's trying to do? It's called as a task scheduler. Yeah. Now we skip all the stuff. Let us go into the offers. Okay, this one I think everyone understands. Now we are also again asking for one CPU. But look at this part. If you come down a bit. Now this got changed. Right? So now we are telling a little bit more information. Okay, slave IDs remain same. Task ID again remains same. But look at this executor. Now we are explicitly saying some executor. Earlier we say set command because we know that it was a command. Now we are saying the explicit executor. Now you can say how Mesos knows that this executor is Java. I do not know anything. It knows how to run your shell commands. Now the question is that how Mesos knows how to run Java. Let us see what is this get executor info is doing. Okay, what it does is it runs a command which launches a Java process with that executor. Are you able to follow what I mean by when I say executor? It do not know what to be done. What I say, I give a shell script which says when you want executor, run this. Then you will get an executor instance. Which means Mesos still don't know how to do Java processing. What they do, they say, okay, this is the API to call. When I want executor, I will run this shell script for you. That shell script will actually set up the whole thing the way I want. All are able to follow how Mesos and different things are working. It's just running any command, and that command is actually which is creating that Java. Let us see this sh file. There's one sh file called runscript.sh. Just search for that. I will show you that sh file. Yeah, run executor.sh. Now what it does, the first thing is that it look at the library path. The library path is the Mesos thing because it needs the Mesos. And what we are doing? We are saying Java minus CP and some class. So running an executor means we are running a Java code, which means the Mesos do not really know it is a Java code. What it says, I will run some script. When you want to have a executor, inside the script you can write whatever you want. All are able to follow till here how the Java and these things are connected. Mesos do not understand Java or any other language. It only knows how to run the commands. This is also true in Yarn. In the Yarn, when you launch an application master, you cannot give a class name. You have to actually give a whole script which actually launches the application master. Very, very similar in Mesos also. You cannot give the actual class. You actually have to say, this is the thing. The reason is that, think that when the executor comes along, you have to give a third-party libraries. All those things you have to be able to control, right? In the script, you can say, what is your class path? Right? What is your class path? How much memory should be given to JVM? It's all up to you to decide. Mesos just says, okay, I will give you this executor with this configurations. Are you able to follow how the things are connected? Okay. Now let us go back to the code. Now, if you go up, now okay, we talked about executor info. What is that executor? Will come back later. Like what exactly executor is doing, we'll come back later. And look at this. Now what we are doing? We are serializing that task and setting aside data of that task itself. Are you able to follow? What was this task? This task is your functional task, which had that body of thing. We will show you how to call it, but that's the body of thing. Now what we are doing? We are serializing it. That's a utility which does the serialization and set it as a byte strings. Which means the way we communicate between the executor and the driver is that we send it as a data into the task. And when the executor gets the task, it can look at the data and deserialize it again. But you should be able to serialize and deserialize because that's the way we do it in the Java. Are you able to follow how we are passing our function from scheduler to the, which means to the underneath system? See, this is the difference because in the Spark, when you run on a Mesos, unless you are using a third-party library, there is no need of shipping the jar. That's the reason they can support REPL. Right? Why not Hadoop Mapper supports REPL? Because when the REPL, you should be able to write any function and send as it is without actually compiling it, building a jar and shipping it. Are you able to follow? The reason we can do it is we can take a function, serialize it and send it as a message rather than sending it as a complete new jar altogether. Are you able to follow till here? Okay. Now, what we do, finally we do the same thing. We say driver launch task. We say singleton because we only have one task here, but you can have multiple stuffs also. Okay, so let us go back to our slides and we see what is the next thing. The next thing is that we have to look at this executor itself, right? Once that task comes to me, what exactly you're doing, and executor is very simple. What it does, task executor, it is a custom executor and it has a main method. The reason it has a main method is that whenever you say Java minus CP, it expects you to have a main method, right? That's the entry point to any Java program. What it does, it has a main method. Inside the main method, the implementation of executor sits. Are you able to follow? Because we are running some Java process, inside a main method, the executor implementation sits. And what we do inside that is, in the Mesos, there's an API called Executor. We create an instance of it. We'll see the code. What we do inside the main method, we create an instance of a Mesos executor where we say what to be done with that tasks. So the idea of executor is it sets up that environment inside which actually your task of function can run. In our example, the task is a function which we want to run. All are able to follow what are the different pieces and how they are connected. And this is the way the Spark used to work in the earlier version. They take a task, they convert it into a function, or they have a function, they convert it into a task, they ship it as a serialization, and on the Mesos, they run using a executor. Okay, let us look at task executor. Okay. Now, again, I am using a thread pool because if I get a multiple task, I should be able to run the multiple functions. That option is there. Now, if you come down, what I am doing is that x equal to new executor, because executor is an interface I want to extend. Here, what I am doing is that I am creating anonymous class. This is very similar to what we do for any of your swing coding and those kind of things. What I am saying is that create a new executor And in the executor, I have to override something called launch task. I think launch task is very self-explanatory. Given a task, execute it. So what it gives you the driver. And if you go to driver right, and if you see, it gives you the task info. Whatever the task info we have created in the driver side, which had your function and etc. etc. That task is for information is given to you. Now how you can read? Come down a little bit back here. So we are running this in a thread pool so that I can have multiple tasks also. And what we are doing, I am first deserializing. Are you able to see? I serialized in the driver side. I got back the data. Now I have a bytes. What I want to do? I want to deserialize back to a function which I want to use. And as of now we are saying it's the task of any. Which means I don't care about the return type because I am not using it. So it's a return type maybe any. But in the future sessions we will see how to keep track of the return type also. But as of now I'm saying it's the task of any and I will deserialize it. Once I have a deserialized, how to run? Running task.run. Which means you know it's the interface of task. What I can say, .run will actually execute the function body. All are able to follow what we have done? We serialize the task from the driver side. Now we got the task here, which has a function inside it. We take out the function out of it. Then we say, okay, run the function as it is. And how we run the function? .run. And after we do run, do you see we send a status update? From the executor, we send a status update to the driver that this task is complete. And do you remember on the driver there was a status update method, which is a callback which will get a callback that we got it, or there is a way also to say there is an exception. As of now, we are not sending any status update, but there is a status update to say something got failed because of this reason, so that you can see that reason in the scheduler side. All are able to follow till here? So what we did is that now we actually moving into this functional programming in the distributed manner. So what it does, we took any Scala function, serialized it and start shipping into the distributed part. And how Mesos is handling, it says, okay, create your own executor which is capable of understanding your function, which deserializes it and actually runs the. Yeah.
How do you run a function using .run?
Sorry?
Running task is a function, right?
Yeah.
So I have seen this running function using parentheses, but .run, what is it?
Oh, okay. That's a good question. The idea is that in Scala, if you don't take parameters, you can skip the brackets. So we like skipping semicolons, things which we don't want. So you can say run this also. Both are same. Okay, so the run means actually open bracket, close bracket, but it has become a habit that not to put it, so it becomes okay. So after the task is run, actually I am not doing anything with the result as of now, because that will come in the future sessions, what to do with the results. What I say, I run the thing and I just complete and say to the driver that this task is complete. Or there is an exception, as of now I am doing a system.exit because I don't want that executor, I want to kill it. But normally you don't do it, you don't kill the executor, you do something else. But that's the easy way out, right? Not do it. Okay, so what we have looked at, we looked at the scheduler, we have looked at the executor. What is left now? Client. You have to see that how to create this task and submit. Let us go to client. I think what is the client is called as? Custom task. There is one client called as custom task. Okay, the way you create the functions, actually here we are creating this multiple task because I want to run the multiple task. We create is that f equal to new functional task, and this is the way to give a function to that object. So which means we have a functional task which has a body of the function, and you know that this function is not going to immediately run because we have told in the API that it's a lazy one. Right? Otherwise what happens if you send like this to a thing, it starts immediately executing that function. So what I'm saying is that don't do it, delay it till I've asked for it. So this is the way to convert any Scala function. Here this Scala function is prints high, and if you look at it, it's actually using a closure. Because index is outside of the function, and these things can be easily done in Scala. Because if you have a closure, it will be automatically serialized. Okay, so what I'm doing, I'm creating two tasks here because these are 0 to 1, which is going to print hello, hi 1. High 0 and high 1. There are two tasks which has an index. So which means I am creating multiple tasks. If you come down a little bit. Now come down. So how you do it is same. So we submit task. Now rather than submitting the strings now, we are actually submitting the function tasks. So in the Spark, what it used to be that all your RDD transformation, they can get converted into this task object and they were submitted on the Mesos. Of course, over a time they have added the abstraction of job and those kind of things. Initially, if you say collect, there's a function underneath it and it goes to the Mesos and executes. All are able to follow why we are following this idea? The reason is that we know most of the RDD functions are Scala functions. Of course, they are working on the HDFS data, which I'm skipping now. I'm not going to implement because my Scala functions are very simple. They just print the stuff. But if you really want it, you can tell that in that function that I want to read from HDFS and do something. It's possible. You can just open use a file system API, read from the HDFS and do some data. Are able to follow what we did? The first example was purely just hello world, where we wanted to run some shell scripts. But this example we started to implement. This is my simplest distributed processing system. What it processes? Scala functions. Are able to follow? You can write any Scala function and run it on the multiple functions. So this is kind of a simplistic version of Spark. Very, very simplistic version. And the idea is that this code should be able to run on any number of machines because Mesos should be able to scale. And how many lines of code it takes? It takes around like 100 or 150 lines, not too many. All the serialization, deserialization, etc., etc. Now this cannot be done so easily in Java pairs. Because in Java there is no concept of this functional body. What you have to do, you have to create an inner class and you have to do that. It will be tricky. But in Scala it's easy, you can take a function and serialize it. Once you have a serialization, then you can start doing the things. All are able to follow? What was the difference between the first example and the second example? Yeah, so what I'm going to do is that, the next slide is that, how to run. Anyway, I'm not going to run because you can run it yourself. This is exactly same. Now only the difference is that, rather than saying hello, distributed thing, you say custom task, but all other parameter remain same. And one more parameter I'm taking is that where is that executor such? Because I need that for executor creation, you have to give the path also. Otherwise, it will have to be hard coded in the code. Other than that, the way you run it will be exactly same on the Mesos. All able to follow what I'm trying to say? So we are passing the script which has the environment and which is, as of now we are using a local file system. If you want, you can use HDFS. For example, if you want to read the data and those kind of things, you can just integrate with the HDFS. All are able to follow. One thing I forgot to show you was my dependency thing. So let us go to the IntelliJ, open build.spt. To do all this, I'm only dependent upon Mesos. There is no dependency on Spark, or there is no dependency on any other library other than Mesos. So this all we are trying to do purely on the Mesos, and everything we are trying to write from the scratch. Are you able to follow till here? Okay. So if you go to slides, I think I am done here. So this completes our part 1. So part 1, what we did, we learnt about Mesos, we learnt about distributed shell, then we learnt about our functional API. Any idea what can be a part 2? The question is that what we can do with these functions, right? What if I have a function where there has to be a shuffle? What if I want to have a return type, right? We want to take something and get a result back. What if I want to keep a counter, not a simple function, a global state? What if I want to do a broadcasting, etc., etc. Same thing what Spark has. The idea of the next few sessions is, can we implement all those on this API? Where I cut the data processing piece, I just say it's just the pure functions, and this API actually holds up across those use cases also. So that is the idea. Today we kind of started with the API. Over the time we want to extend. And these are the references, actually most of the references on my blog itself, because this project was started as a blog, and a lot of the setup and code is there in the blog. You can look at it and go through it. Whatever I talked is actually in the blog. And there are not too many blogs on Mesos, because most of other Mesos blogs actually refer me itself. That's what I've seen. So, but if you are able to find more, just let me know. There are some blogs from Mesosphere, but they don't talk much about the open source Mesos. They talk about their distribution and those kind of things. Okay? All able to follow what we are trying to do here? We are trying to do something what Spark did like 5 years back. And we want to trace those step by step, where you kind of understand what are the different abstraction, and with this abstraction what we can. Okay, so that completes our session. I think we are very on time, right? 1:30. So thanks for coming.